Hello and welcome to the best React course online. Wow, that's a bit of bold statement. And okay, I may be biased here, but I am definitely forward to us diving into some fun topics and coming out the other and as great React developers. This course tries to build onto its topic and gets more and more advanced as you progress. Trust me, if you go through everything, you will come out the other end confident with React project, manage and even lead React projects in your company. Now, before we dive into coding, building projects, and learning about React, I want to take a moment and understand why React exists. What problem does it solve? Why it makes front-end development easier? And also, what principles we need to understand to be more than the average React uh, You see, a lot of times people learn a tool, a library, or a framework without understanding the core principles that make it great. By learning these things, first we will have a foundation as we move through the course and understand what the best practices are. The goal of this course is not to be another researcher like thousands of other already exist. The goal is to make you a reactive helper that can think on your own, make good architectural decisions, and lead projects instead of only following tutorials. Therefore, in this section, let's dive into the important principles that will help us get through this course. If you are new to React, some of these principles may be hard to understand at this, and we will keep revisiting them throughout the course. For those that have already worked with React, you may learn a thing or so. Hang in there. My goal by the end of this section is for you to be able to explain to other programmers of React without writing a single line of code. I do recommend that this section is something you come back to after you have passed through the entire course. Alright, enough talk. Let's see. Now that came out in 2013, but what do we have before then, before React? Well, the front end landscape was very different on that time. Initially, back in the 90s and early 2000s, we just had basic HMO access in JavaScript. HTML displayed the text on our web pages. CSS and the styles and JavaScript allows us to have some interested websites. And initially, it was just started with simple forms where we send from the backend. When we go to a URL, all these files, and when a user, let's say, submits a form, we simply send that back to the server to store that information. Now, if a user clicked on, let's say, a link in the page, well, once again, we simply request the new HTML file and the new page from the server, and that gets sent to the front end. And that's how websites work for many years. But there's a problem here. You see all these websites where they run on different browsers, and all these browsers were worked on by different groups of developers. So each one of these browsers implemented while their browsers others differently. So what happened was, as we wanted to use more and more JavaScript in our web pages, we had to account for all these browsers that sometimes work differently from each other. And we had to accommodate JavaScript to work with these different browsers. Now, eventually, we had jQuery come out, which allowed developers to easily interact with the document object model or the DOM across all these browsers. You see, back in the day, if we went to, let's see, Hacker News over here, clicked on Views, Developers, and then Developers Tools, and we went to Elements here. This is the DOM. The DOM that well is our page. It displays exactly how our page should look like, and it's a tree-like structure. And JavaScript, all it does is modify this dump. You can remove elements, you can update elements, And although there's now more similarities and compatibility across different browsers, back in the day, we didn't have jQuery. So jQuery made developers happy because it had a unified, easy API that kind of looked like this. Instead of a developer trying to think about how to work with the DOM image of the different browsers. The jQuery said, hey, we will take care of that things. Just this is a syntax we'll use that works across all browsers. And you can manipulate the front end or the DOM however you want. So that was great. But would this power developers started building bigger and bigger applications instead of just something small? We started getting these massive applications like Facebook, where you got to log in, look at the newsfeed, message friends, and as website turn into these full applications that people can interact with, besides just requesting more and more pages like a blog. Well, libraries like Backbone JS just came out because, well, our JavaScript files started getting bigger and bigger and bigger. Libraries like Backbone allowed us to organize these JavaScript files in a small way, and because it becomes easier and easier to work with the DOM, we had the worth of a single page application. You see, traditionally we just had a emails files for each page, and every time we moved to a different page, we would request from the server, well, the email file, the access file, and the JavaScript file, which usually contain jQuery for each time we click on a link. But with more advancement, like we had with jQuery, Backbone, and something called Ajax, we now had a different system. What generally happen now is we focus less on HTML and lot more in JavaScript. You only load the application code here instead of us making new requests to the server, where we returned a new document instead. Now our application acted more like a desktop application where we stay on the same page the entire time, and the JavaScript file simply changes or updates the email file or the DOM to display new things. So you were able to sign into an application and interact with that application without ever speaking to the server anymore. And this way of writing applications or single page applications become really, really popular. And in 2010, which was created by Google, really become the standard way of building application, AngularJS. Now, unlike jQuery, Angular allowed developers to build these large applications by forming these containers that well wrapped your project. And because it was created by a Google, it had a lot of power. Because people said, well, this is the thing, everything is organized here. We have these large JavaScript files, but we can organize them this way. You had code now that now has better containers, where you had things like controllers, views, models. And this idea of a model view controller, where each part of the application or each JavaScript file was divided into different things that it did. This idea of organizing our large code so they are easier to work with as teams get larger and larger really made AngularJS popular, but there was a problem. You see, things started getting more and more uh, complex because of this. As things get bigger and bigger, more things have to happen. Users are clicking on this button, which changes this area, which in turn changes that area, and which has now to display this information. Uh, we have more and more complexity. And although frameworks like AngularJS came out, people started to notice it's getting harder and harder to find bugs in the code, and started to notice this part of the app while affecting the other things. Meanwhile, Facebook developers were finding it hard as well on their end to maintain their app, especially their Facebook ads. You see, the Facebook ads app got more and more features. More and more people were added to the team. Now the growing number of lines of code, the growing number of people working on the app, and their uh, app become really difficult to handle, and each update would cause more and more issues where you had all these arrows relating to each other, pointing to each other. And after a while, the engineers of Facebook just could not keep with the way that they are. They needed to upgrade their code base. And this is not just special in the front end world, this is all over programming. It's why we need good architecture. We need to think about how we organize our code, how we manipulate data, and how that data flows through uh, our program. So Facebook came up with a solution. That solution worked really well for them. That is 2013, they released React to the developer community at 2013, and their solution was really good. And it took off because React developed a whole new way to build front-end application. Now, it also happened that in 2014, AngularJS realized that the way that they have architected their frameworks just did not allow good applications to be built anymore. So they decided in 2014 that they are going to rewrite the entire library, call it Angular. But because they wanted to do an entire rewrite, a lot of people during that time moved to React. So combined with the fact that AngularJS was getting a complete new rewrite, Facebook was backing React, and the great principles that React introduced made it what it is today. That is, it become the most popular and tool with the most job demand across the world, and being used by very large companies like Airbnb, Uber, Netflix, Twitter, Reddit, Pinterest, Wix, PayPal, Stripe, Tumblr, Walmart. However, what made React so great? What were these principles that made it jump from something that Facebook used to something that developers all over the world use? Let's find out in the next section. Now, the success of React comes down to four key things. And these React concepts are we going to go over in the next our four videos. But in this one, let's talk about the first one. And the first one, React says, hey, don't touch the DOM. I will do it. What do you mean this? You see, many existing frameworks and libraries before React were directly manipulating this DOM uh, on every page. First, let's just go over what a DOM is. If you remember, DOM is our document object model. It's what the browser uses to display a website or web page. And JavaScript is simply manipulating. Uh, For example, if I right click over here and select inspect, and you will see that here if I click on what we will get a little flash saying that hey, JavaScript just updated this. If I click again, I get a little flash. The DOM is just the uh, tree representation of the page. We start all the way up from the HTML, and websites were built using things like this. All these ways that browser allowed us to manipulate the DOM. They gave us the DOM API that we could access using something like inner HTML or get element by ID. Get elements by tag name. This API allowed us to traverse the DOM, access any node we wanted to. Maybe and remove them, add new nodes, and before React. This is what libraries did. You either did this manually, or you use jQuery, or you use some sort of a library that allows you to use this in a simple fashion. You see, this way of programming was called imperative. That is an imperative paradigm. You directly change individual parts of your app in response to various user events. So you had, let's say, your JavaScript file, you had say, hey, if user is logged in, uh, well, then go change that little icon over here to the user's profile. And now that the user is logged in, well, also show profile here. Okay, so JavaScript goes changes the home and updates the profile page. Now that we also need to display things. Let's do that. Well, modify the tone. And all right, that's good. We are good. By the way, it's been 5 seconds and we need to display a chat over here. Okay, I'm going to go and do that now. This sounds intuitive, but the problem with this imperative approach is that it becomes difficult uh, to see the relationship between events and all these edge cases. Remember this diagram over here where we had AngularJS and that all of a sudden had all these relationships affecting each other and all these errors pointing to different things. Well, instead of this imperative approach, React came up with a novel concept, a more declarative approach, and this is what React says to you. Hey, DOM manipulation is one of the biggest performance bottlenecks. It takes a long time for DOM changes to happen. The browser has to do two really intensive works. One is to depend, that is change an element and add it into a page, and then the road which is to relocate the layout of the page and move things around if needed. So changing the DOM was a really expensive operation. So React says, hey, you know that, let me take care that I will find the best way for me to change the DOM and just declare to me what your app looks like. So all we need to do is to say, hey, this is a JavaScript object of how I want the app to look, and React is going to hold this JavaScript object, this massive blueprint of how things should look. And based on this blueprint that we give it, React just says, hey, just tell me what the page should look like, and I will take care of it. I'll do everything for I find the best way to use the DOM. You are never going to this, just tell me what the page should look like. This declarative paradigm is called that because we declare that hey, this is what the state or data of our app should be like, and based on this date, well, then just make those changes. So if a user is logged in, then React already knows exactly what to update and what to do. Now this idea of a declarative style means that we didn't have to directly say do this, and if this happens, then do that, where we just say one by one exactly what should happen. Instead, we tell if this is the state of our app, and React automatically just returns it for us. The difference is that all the different states are accounted for in one place. That is one big JavaScript objective that describes how our app should look. And this resulted in less complexity, better code quality, and faster developer times. So it created this whole idea of, hey, you can build web interfaces without touching the DOM. And this is where the name React came from. The name React is simply saying, hey, based on whatever the state or data of the app is that describes our app. I'm just going to react to it and change everything for you so that you get the display that you want. So we learned that React had this revolutionary idea of let me handle the DOM update because I know the best way to do that, the most affordable way, just tell me what the page should look like. And big game changer was this idea of building blocks and designing around the concept of three. Just like you see in this app, how each square or rectangle has different color. While these are all components, each of these individual pieces create this whole app. React had this idea of small components that you put them together to form bigger components. So you had the profile picture component, you had the add component, and then you had the navigation uh, bar component. And within here, you had components containing components. So you had a component in here that was surrounded by another component that was surrounded by an ever bigger component, just like Lego blocks. And all these small components, whether they are large or big, can be used in different places. For example, I can have this component just copied over to multiple locations because while they are the same thing, and I can even move these over to different projects and so people can build these components like material UI components that I could just copy and paste this code and add it to my projects. Like you had different components libraries like React, Bootstrap again, or something like Looping. So people can now share these components across different websites, across different projects, and they all will all work. Now, this idea of components and React, uh, in a simple term, it's just plain JavaScript functions that you write. So we have the state of flow that is any data that describes our app. For example, the user is logged in, whether it's true or false or maybe something else. The components are created based on that data. And simply as functions and don't worry, don't get intimidated by this. This is something that you cover throughout the course, but components are simply just JavaScript functions that receive some sort of input or attributes which uh, we call prompt. And in return, it returns this thing that kind of looks like HTML, but inside of JavaScript. And these components can be built like this as a function or even as a class. But the key here is that based on the state and these components that we build, we have an entire component that we can add to our page and reuse maybe over here as well if we wanted to just like Lego blocks. Now here is a simple React to-do application and I'm going to be using something called the React uh, developer tools which I recommend you install as well as the Chrome web register. You can add it to Google as an extension and what it allows you is when you click view developer tools, you will now have the elements stack which shows you the door of your app which you can see over here, but also a new tab called React. And this React plugin actually allows you to see the components that build an application. Now you can see over here that this is not exactly HTML. We are creating custom text like filtered list or footer that is not valid HTML, but you will see that inside here. All of these are actually well built by XML elements like footer So again, this idea of a components architecture means that we can have some sort of data about our application and we build these components ourselves, and these components are what we call React components that we build out of XML tags that simplify a component. And each of these components work together to eventually have our app. And this component architecture is really, really key in because it allows us to reuse and share components between projects so that if you wanted a date picker on your app, well, instead of just building it yourself, you can just Google code it and say React date picker component and just somebody else. But there's two more key concepts to get through, so let's do that in the next week. So we have learned the first two concepts. The third concept that made to React really popular is this idea of UI directional data flow. Unidirectional data flow by use of this. Well, so far we understand that React is just a JavaScript library that allows us to write more JavaScript to have interactivity on our website. And in fact, we have this idea of state, which you can think of it as a JavaScript object that describes our app. So all the data of our app is within the state. And then we also learn about this idea of components that we can build using React with this weird HTML looking thing. But inside of our JavaScript files, this idea of state, which is the data over app, works with the components which are built using uh, what we'll eventually learn is called JSX. It's XML like syntax inside of JavaScript. All these combine to essentially give our React library things that is the component that we have built. The state over application, and you can think of this as a function. A React library is simply a function that we give all these things. So what it's going to is it going to create what we call a virtual DOM, that is it creates a JavaScript version of the DOM. Remember this is not the DOM we installed it. The React plugin to have something like the element tab that is not exactly, and this is just a JavaScript object that describes our app. What we call this virtual DOM, which is a tree-like object like this that gives React a blueprint of how it should update the actual DOM. So what happens then is React takes all of this and say, hey, here is the actual DOM or the document object model of the website. And the React little over here is going to look at the blueprint of what it needs to build and modify the DOM for us. Now, this idea of unidirectional data flow means that anytime we want something to change on our web page, well, the state has to change. This is the data has to change in our app. So, what happens if, as a user, I click on, let's say, well, I click on a button, React is going to intercept that and say, hey, somebody just clicked on the button. How does that? Let's say I click on the state React is going to go on this and take action. How are we going to change this? Well, internally we would say that if somebody clicks on the sign up, then it now going to now say this, and React as soon as the state changes reacts to that change and say, hey, the state just changed. combine the new state and the components we have and update the DOM, you see the data only flows one way. A better way to think about this is like this. Our application is simply built with this virtual dump, this JavaScript object that describes our app, and as soon as the state changes, it's going to trickle down that information and let everybody know, hey, the state just changed. If it's logged in, if now false display this version of the app data can never move on. So, for example, the state as we have learned can live in different locations, different components. And if the state, let's say, changes here, the data can never move up. That is, all these changes can only trickle down. Now, this concept is hard to explain without actually seeing any code. So, if you don't get this right away, we'll explore this idea and revisit this idea of one-way data flow throughout the course. But the key takeaway here is that by having this restriction of data only being able to move down from the state of our application all the way to the node, and if any changes or events happen, that change the state while we go back to the state, and that state change trickles down to different components. And one direction is a restriction on how data can move through our app, and by adding this restriction, it's really easy to debug code. For example, if there is something wrong with our sign function, I can go to wherever the state is logged in this. Let's say it lives in this top component here. I can go over here and know that this is where the bug is happening, and whatever is underneath this component, well, that's it. I don't have to look outside of the component of this tree was massive with thousands and millions of components. I only have to look in the place where the data exists and where the data flows through. Again, this is a really hard concept that we will explore throughout this course, but this idea of one-way data flow is the restriction, and because of this restriction, it is easier for us to understand how our app works. Unlike the arrows and the points that we saw with an Angular app where things got confusing, really, really is. We learned the four main concepts that really made React take off. Uh, it gave developers a whole new way to think about their applications and how we build them. It was architected in such a way that it made building large-scale applications a lot more pleasant than what we had before. Now, since then, a lot of libraries have come out that have taken some of the concepts. Angular was rewritten to a new version that is more in line with these concepts. And libraries like Vue are also using these concepts because people have realized that these are some really good principles. So now you have things like React, Angular, Vue that developers are using to build front-end applications. But React really had this initial jump, and it's still the most popular library and the library with the most job demand because it was the first to introduce these principles. And the beauty is that although we have not written any code, you have now learned a little bit about some of the keywords that will encounter throughout this code. And don't worry, we are 100% just now because all of these things are something that we need to practice with projects, with really, really simple projects. But now, when you hear the words like declarative components, state props, virtual DOM, you will have an idea of what it is because we have learned that React is a declarative paradigm. That is, instead of telling our APS exactly what to do, we simply give it some state and some components that are built with some things. And these components sometimes receive properties which are called props. We give all that information a giant JavaScript object in a declarative way, which creates a virtual DOM in JavaScript. And that virtual DOM is used by the React library to update the DOM for us in a declarative way. But your question is this: how do I become the best React developer I can be? And to be a great React developer, it actually comes down to three things. Three things that really good senior React developer do well, and we are going to focus on these three skills throughout the course. The first one is to decide components. Really good React developers decide what is component, how much do we want to break down a component, how do we build these reusable component as we have seen, and deciding on how to break down the app into different components is a very important skill. The next thing is to decide the state and where it lives. Now we are going to explore this idea of state or data or app a lot more, but this state can live in different locations in our virtual DOM. So whether we put the state here or we put the state here or here in multiple things, that decision is very important in architecting your app. And really good developers do a really good job placing state in the appropriate component. The third is what changes should we make when the state changes based on what this JavaScript object called state is changed. We have to decide what to render, what part of the virtual DOM changing. And deciding on this is also important because it has huge effect on performance. Now don't worry, these are the things that we are going to really work on, but I want to this is as a reference because if you want to become a senior developer, these are the things that you have to become really good at making these decisions and knowing when something is good and when something is bad. We are going to explore that and a lot more. The next section, I will see you in the next one. Welcome back, everybody. In this lesson, I'm going to show you how you can set up your environment so that you can follow this course with all of the tools that I have and that you will see throughout the course along the way. Mention some alternatives that you might see. It's entirely up to you because these are all just tools and I simply have my own setup that I use throughout this course. Now, the first thing you need to install is your editor. So if you already have an editor that you prefer, such as Sublime or Atom or even an IDE that Storm, I like Visual Studio Code, so that's what I see. So in order for you to get Visual Studio Code, simply go to this link that I am going to download and your resources and then hit the download format button. Now, what this will do is this will trigger the installation. So simply choose the place where you want to download the actual Visual Studio Code, and I'm going to choose desktop, and this will download the zip folder for you. Then you simply just open up the zip, and now you will have your Visual Studio Code application which you saved as your zip folder. So now if I go to my desktop folder, I see right there. So just double click and to open it and then allow your Mac to open Visual Studio Code because it's downloaded from the internet. You need to give it installation as now. Once you have given it permission, Visual Studio Code is up and running. So editor that I have used, the only thing I would suggest you probably is to add the code cell commands to your terminal. Now, we will explain more about what that actually is in a little bit later. But right now, in order for you to add it, you simply hold Command Shift and press P. Then you are going to type command, and here you will see cell command installed. So simply click that, and then it will install and the code command to your path. Now, once you have your path set up, you are now able to use the code dot command to open up files and folders inside of your terminal, which we will do it a lot in this course. Now, what is this terminal? Well, the terminal is actually going to be the main way that we navigate well as modify our files, as you will see in this course. Now by default Mac comes with a terminal, so in order for you to access it, simply go to your Spotlight search and type terminal. Once you have that, just open up the first thing you see, and this will be the terminal used throughout this course. Now with this terminal, what we need to do next is actually install Node. Now the easiest way for us to install Node is actually to use something called and VM version manager. Now in order to install and VM, simply go to the link that I am going to provide you inside of your resource folder. And then once you navigate to this link, scroll down to this section called installation and update, and simply copy this line and then paste it into your terminal. What this will do is this will clone down the npm package and then add it to your existing cell, which is the thing that we are running inside of your terminal. Now, once we have an VM, we have to actually close our terminal and then relaunch it. Now, once you have reopened your terminal, type in command shift, and if you see nothing listed, then this means that SVM is not yet loaded to our set. So what we have to do is we have to actually scroll down here, and we can see inside of these instructions right here on OS X is see that there is no end script that what we have a base profile. Now you can do this by simply typing nano and this till the sign spot bar profile. Now if you hit this and nothing occurs, meaning that there is no path profile instead of nano. Replacing this with a touch and then run nano profile again, because touch will open a new file for you. So inside of our profile, if at the very bottom we see nothing related to end PVM, this line of running resource path RC, so let's just add that in this. You can also copy paste this if you want. Once we have that, we just need to save by hitting command X. It will ask us if we want to save, we hit Y and then we hit enter. And now what we need to do is we need to type the source profile to upload and run our profile that we have just made across. And now if we type in npm, we will see that there is something here instead of an pvm command. So now we know where we need to do is actually install node using npm, and then way we do that is we can actually first figure out what node version we want. So let's go to the node website, which I will be linked to you as well inside of your resources, and here we will see that the latest version is 10.16.0, and manually download this from the website we can use, and go back to your terminal and you can type in npm install 10.16.0 or any other version of node that you want to use. Now you can also type npm install node, and this will give you the latest version of node here. So for us, I'm just going to use 10.16.0, and now this will install the node version that we need. Once it's done installing, what we need to do is make sure that we use it. So in order to do that, we can just say npm use 10.16.0, and now we will be using the right version of node. We will also see that npm version 6.9.0 and npm that we are going to use to manage the package of our JavaScript. So this is really good. We have both of them installed now, and we can check by typing -v And here we see that we have both installed on our computer. So at this point, it's actually perfectly fine to continue with this course. And you have Node, you have NPM, you have your terminal, and you have the editor. Now the thing is that I use ReArm instead of NPM Johanna, simply another package manager that Facebook made during a time when EMT has, but NPM is perfectly stable now, and both are pretty equal in terms of the features and the speed regarding package management. So if you want to use NPM and not install Yarn, you can definitely do so. You can simply look at the different commands with NPM that you need in order to run commands instead of using the Yarn ones that do. But if you want to use Yarn, just go to the Yarn link that I provide you, scroll down to the installation script and then copy that line right there. Then you go back to your terminal, we clear it and then we paste it in. And now this will install Yarn into your computer. Now once you have Yarn, you just need to check whether or not it is. So simply Yarn dash version, and if you see a version now, you also have Yarn. So now you are able to do everything that I do in this course with Yarn, and you can switch between Yarn and NV freely. Ideally in one project, however, you should use either one of the other. You should not use both NPM and Yarn in the same folder. Now, keeping that in mind, you are fully set up to move on with this course. So I will see you in the next lesson, everyone, and welcome back. In this video, I want to quickly show you how you can get your environmental setup so that along inside of this course, if you are on a Windows computer, now in the Windows computer, there is a couple of different terminal options. You have the main one that I think is very useful is the one that comes integrated with Visual Studio Code. The benefit of this as well is that because I use Visual Studio Code as my editor, if you are unfamiliar with the EDS, you can easily use Visual Studio Code and you will be able to follow everything that I am doing with my editor, because we both would end up using the exact same editor. So in order to use Visual Studio Code, I'm going to paste for you a link inside of your resource so you can use to get the this. So simply hit download for Windows and wait for the download to complete. Once your Visual Studio Code finishes downloading, simply go to the folder that you set in. So in my case, it's my download folder, and just simply double click to install it. Now inside of here, you are going to be asked for a license agreement. So simply accept that agreement, and then you will have these boxes that you can check. Now I would probably check all the ones that are unchecked, but what this allows you to use Visual Studio Code through different settings on your computer, so you can use it to open up your projects. Simply hit next and then install. Once it's finished, we can simply launch Visual Studio Code, and then inside a Visual Studio Code, you now have your editor. So in order for you to actually open up the terminal that I have here, simply go up to the terminal tab and hit new terminal. And this will now open up the terminal that you have by default set up inside of your Windows computer. If you have installed other cells, you will be able to select them from the drop down of this. But in my case, I only have power, which is the default cell that comes with the computer. So what I am going to do now is I am going to actually install a different one called uh, Git Bash. Git. So you are now able to access the underlying Git project and Git folders that we will use throughout this course, because we want to push to GitHub. So use the link that I provided for you and simply paste it in your browser. Now this will download this the same way that we just downloaded Visual Studio Code, and just save it wherever you want. Once it's finished downloading, go to folder where it's downloaded to and simply run it as well, like other software. Now this will ask you if you allow it to make changes. Now you go through yes, because this will install BAS instead of PowerShell, which comes with much easier to understand controls. Now here I will ask you if you wanted to allow you to install different things, and in my case I just want to add another icon on the desktop so it's easy to launch. And then by default I will ask you whatever you want to use. So usually them is the one that people are comfortable with, or Visual Studio Code, which we just download. If you want it to be the one that opens whenever you want to modify files and text files, but we will explore that a little more. For now I am just going to stick to them and hit next, and then I want to run it from my command line. And then I want to also use OpenSSL in order to validate my get, and you can just think of this. And for here, you can also use GitBash and terminal emulator. So this one is entirely up to you. I personally, I'm going to use the Git provided, and then I am just going to hit this again. Experimental is set up to you whether or not you want to opt in or not to these new command. It does not really matter. I'm not going to opt in, and I'm just going to wait for the install to finish. Now once everything is installed, simply hit finish and then go back to your Visual Studio Code and close it. So we need to actually access the new terminal because we have a new cell. So to do this, just reopen Visual Studio Code after you have opened it, and then inside of this drop down, what we are going to do is we are going to hit select default cell, and we are going to choose our get base. This will allow our main terminal wherever we add a new to use our new git base. And the way to do that now is simply hit this plus icon, which you will see is now base, and then you just close your old PowerShell by switching back into, and it will go to garbage. And now you have a base terminal. Now if you see these colors, then you switch to BAS. That means that you are running the uh, min Mic emulator. If you remember through this settings, so this is actually a quality of a live emulator. It just makes different things in the terminal prettier as well as easier to understand. And reason about, you can of course run other emulator if you want, such as GSL, which is what I want with my phone. But in our case, Menti is fine for Windows. Now, what we need to install next is Node is actually what's going to allow us to run JavaScript inside of our terminal. What we have to do is we have to go to this website of Node.js and simply download the installer to whatever with your Windows is. So minus 64, I am just going to download the 64-bit. Once it's finished downloading, open the folder and then just run the Node installer. Now Node is what we need in order for us to run our JavaScript as well as manage our JavaScript packages for all of the applications that will be. So simply hit next, accept the licensing agreement, install Node, and then hit next again, and finally install. Now Node also comes with NPM, which is no package manager, and we want to guess here as well and ask if it allows us to make changes to our devices. And no package manager NP is what allows us to manage different versions of Node. Now the versions of the or come with different features, and Node is always being updated. But we want to just use the latest version of Node at the time of when you watch this video. And usually that's what this link will recommend you as well. I will try and give you the latest version. So simply wait until our node is finished installing, and once it's finished, simply head finish. Now we have to make sure that node and npm are properly installed on our computer. So the way we do that is we just have to close our Visual Studio Code and reopen it again, because we need to see and load a new version of our terminal. And once our terminal comes in, we simply type in no test, and we should see some numbers. So this will tell us the version of node that we have installed. If we had npm, we'll see the npm version. Now that you have npm or node, you can actually run through this course. The only thing is that I use Yarn as my package manager instead of npm. Now Yarn and npm are pretty much the same thing. The only thing was that there was a period of time where npm used and that Facebook did was they created Yarn so that it was a proper. But npm has seen this. Now you can easily Google all of the commands that you need that are the same replacement for what's used in Yarn. If you want to use just use npm, but if you want to use Yarn, I'm going to show you this. Simply copy the resource that I have given you inside of your folder that says Yarn, and then paste it into your browser. And once you are on this page, make sure your operating system is Windows and your version is this. Then you just click download installer. Now you will see here that it says that we can only do this after we have installed Node.js. So with this, once it's finished, we simply go to where we have installed it and run the installer. We are going to accept the license, hit next, and finally hit and stop. We want to allow it to make changes and be finished, and now we need to go back to our Visual Studio Code, close it again and return it, because we need to make sure that we have the version of Yarn installed on our computer. So what we can do inside of our terminal is just type yarn-v once it's finished downloading, and we should see the version that we just installed, and with this your environment is now set up for the rest of the.
Hello everyone and welcome back. In this video we are going to start building out our first React application. And the application is going to be this Monsters Rolodex project. What this project is, it's a single page application React app, and what it lists is a bunch of these different monsters. You can also see the monsters and actually filter them using the search bar. So let's say, for example, we wanted to filter for Clementine. As we start typing, we will see that we will start filtering out any monster that does not have a name where it matches what we typed in the string. It's a very simple application, but it'll teach us a lot about how React works and how React application is structured. Getting started with a React application might seem very complicated because there's a lot of files that we would typically have to come up with and write from scratch if we wanted to actually write out an application in React. However, luckily for us, Facebook has actually created a tool that makes this significantly easier. And this tool is called Create React App. Create React App is pretty much just a tool that you can run inside of your command line. And what it will do for you is it will scaffold out a React project, a very bare bones React project. And scaffolding just means that it will set up all of the necessary files and folders and then link them appropriately so that you can get started with a React application. And that's what we're going to use to really understand how it works. Here inside of React.js's own documentation on Create React App, you'll see that it's very simple. It says, of course, that it is a comfortable environment for learning React and is the best way to start building a new single-page application. So we're going to deep dive into what this means, all of the different files and the different setups that it provides for you. And then we're going to deep dive into how we can do this without Create React App later in the course. So we're going to fully understand how all of this works under the hood, but for now, we're just going to leverage it so that it makes our lives easier so we can get started with our first React application. So here you'll see what it says is that we want to run this command, npx create React app, and then the name of the application that we want to call. So what it means is just that when it builds it for us, it will build it into a folder, and we want to give it some kind of name. So here, let's go into our terminal, and we're going to type exactly what it said, npx create React app, and then the name of our folder, which it's going to actually put all of the files into that represents our project. So I'm just going to call it monsters Rolodex right here. Now what's happening is that you will see that npx is actually downloading the package and the latest version of create React app in order to actually help us scaffold out this monsters Rolodex project. Scaffold being actually generating, again, the files and folders required for our application to actually work. So this is really handy. But in this process, you might be wondering, what is npx? What is create React app? And let's take a little deep dive into all of these things while we're waiting for our project to be built. So I'm going to open a new tab. And what I'm also going to do is that I am going to show you npm versus npx, because that'll actually be the best way to understand what npx does. And npx is actually a tool that gets included with npm version 5.2 and greater. So npx is actually a tool that lives within npm. So npm, as we know, is Node Package Manager. These packages are just these different node-related libraries or files and folders that get created by different tool developers online that we can use to help us with our Node projects or JavaScript-based projects. What this means is that npm is what we use to coordinate and also leverage these different packages that we download. Create React app is an example of one of these. It's just this tool that Facebook built that allows us to quickly and easily build out React applications. So we can do this with npm and not npx. The thing about npm is that npm is a installation as well as a executable environment. So what this means is that we can install directly Create React app and all of these different packages onto our local project, local being this local folder I have, or we can install it globally on our computer. So if I do npm install and then the name, let's say Create React app, what this will do is it will install and download Create React app locally into this folder. So that means that anything inside of this folder can leverage Create React app. However, if I wanted to use Create React app in multiple projects, but I only wanted one version of it, because Create React app, as we know, is a package created by Facebook, and Facebook could be constantly updating it. So you might have numerous versions of Create React app in multiple different projects. But what if we want to always to leverage one version of it across our entire computer? Well, here it's very easy. We just say npm install -g, which means global. So install it globally and then create React app. So this is typically how we used to do it before npx, meaning that what we had to do is we had to download down the latest version of Create React app if we wanted to use all of the latest features in order to build our React applications. So let me give you an example of what we can do with a very simple library, and it's called cowsay. So cowsay is a library that just draws out this cow that says whatever we pass it. So for example, if I wanted it globally again, what I do is npm install or npm I, which is shorthand for install, -g, so globally make this available, and I want cowsay. So now it's going to download, again, as we know with npm, all of the appropriate files and install it globally. So what I can do now is I can say cowsay hello. And you'll see that it draws a little cow because I have this cowsay project globally installed, and it will just say the text that I passed it, which is hello. So if I wanted to see where I have this cowsay project, I could do npm list, which just lists out the location of a package. So if I say npm list cowsay, what I'm saying is that I want you to check the current folder for some package called cowsay. And when you see this, you'll see that it's empty. Of course it is. The reason why is we installed it globally. So if I wanted to check npm, again, list -g and then cowsay, Now it's going to check the global location, which is your path location where we save all of our globally installed packages with npm. And now we say that, oh, there is a version of Causa here, version 1.5.0. So here you can see that we have with npm, when we installed this library and then wanted to use it, we had to install it somewhere on our disk, our hard drive, our computer. This could be in our local project folder, or this could be globally on our computer. So what I'm going to do now is I'm going to delete this Causa project from our global list. So I'm going to say npm uninstall -g, because again, it's global, Causa. So now this is going to get rid of it. You'll see that it says removed 41 packages. And again, if we just double check list-g Causa, what we'll see is that it's empty. So this is exactly what we wanted. So now that we have this, let's understand what npx does instead. So instead, I'm going to say npx Causa hello. And now if we run this, what we'll see is that we're still downloading the package Causa because we don't have it, and it will execute it immediately. Before, when we did it with npm, remember, we downloaded it, and then we had to run Causa and then call it. So here, what npx does is it directly installs all of the required files for this package, and it executes it immediately. So what this means, though, is that is not all it is, just that it downloaded and it exited quickly? No. In fact, if we check npm list Causa locally, we'll see that it's empty. If we check npm list-g Causa, what we'll also see is that it's empty. So what this means is that npx downloads the packages, the latest package for Causa, so the latest version of it, and it executes it immediately, and then it deletes it from the disk. Now you might be wondering, why do we want to do this? Well, the main advantage is that, one, you don't have to clog up your environment or your disk with all of these different packages that you have to make sure that if you're running the latest version of it. Certain things like this, you might just want to use when you need it and make sure that when you use it, you're using the latest version. So the benefit here is that when you call npx, you are going to ask for the latest version. Now, of course, you can specify with a argument at version. So you can say, oh, I want this exact version instead, and npx will download that exact version. But if you don't pass that, what it'll do is it'll just download the latest version and then execute it and then delete it. So that's why it's super useful, because this way we don't have to think and manage the different packages that we're leveraging. And this is really useful for something like Create React App, because chances are you just want to use the Create React App library to start up a new React project when you need to. When you don't want to use it. And if we go back to our CRA folder where we were running our Create React App with npx to get the latest folder, here we see that now it's done. We have our application called Monsters Rolodex, and we can see it right here. So let's cd into it. And what we're going to do is we are going to talk and break down about what got generated with Create React App in the next video. So here, once again, let me just go over quickly what we did. We used npx to download the Create React App package, the latest version of it. We generated our React application, Monsters Rolodex, and then with npx, automatically, it deleted Create React App so it doesn't take up any space on our computer. And now we have our Monsters Rolodex React project that Create React App has scaffolded for us, and we are going to break down what is inside. So with that, I'll see you in the next video. Welcome back, everyone. In the last video, we took a look at what files and folders got built for us by Create React App, and inside of package.json, we took a look at our start script. We took a look at also the files related to setting up the initial project, which is the index.js file and the index.html file, and how React DOM at a high level helps us render out our application. In this video, we are going to deep dive into the 3 remaining scripts inside of React. And what we're going to do as well is we will take a look at some of these other files and how they relate to these scripts. So diving into the next one, which is build. What is build? So right now, what I want you to understand is that when we ran script start, this is just taking our application code and pushing it directly through our local port of 3000, so on our computer, and our browser is just accessing it directly. It doesn't have to go through our network, which is our Wi-Fi or internet connection or anything like that, in order to get the related files in order to run our application. It doesn't need to. It's all local on our computer. So this is incredibly efficient and fast. We don't even need to think about optimizing it at all. But when we're actually hosting our application live somewhere so that anybody can access our website, they need to leverage their internet connection. And as we know, internet connection varies and it can be very slow. So what needs to happen is our code needs to be much more optimized so that it's as small and efficiently served as possible. And that's really what this build step does. So going back to our terminal, if we do something like we call yarn or npm, whichever one you prefer once again, and we call build, what will happen is that React scripts will actually generate an optimal build for us, an optimal build folder. And what this is doing is it is taking all of this code that we have. So all of these separate files and all of these different JavaScript and CSS files. And what it'll do is it'll actually group it all into one file for each related JS, CSS, index HTML, and it will make it as optimal as possible. And it will put it all inside of a new folder right here called build. So if you go into this, what you'll see is that there's our index.html file again. But inside of here, you see that it's very condensed. And what you'll notice is that in here is all of the code related to our application. You'll see that there's all this like really funky looking JavaScript code, and it's really tight, and it's just using these very reduced variable names. And the reason for this is because it's trying to create the most optimal low memory version of our application as possible. So that's really what's happening here. It's taking all of these files that we have, all these potential JavaScript files that we're going to write throughout this course, and it's just condensing it down into the fastest version that can be sent over an internet connection for a browser to consume. So that's really all this build is doing for us. So going back to our package.json, we want to look at test. So testing we're going to cover extensively later in the course. At a high level, all you need to know is that tests are just ways for us to make sure that the code that we write for our React application does what we expect it to. Inside, you'll see that there is a app.test file. Don't look at the content for now. This is not as important right now. But essentially what it is that it's a test file that is trying to test something in specific. In this particular case, it's testing the app.js file. We haven't looked at these yet, but all you need to know at a high level is that this test is related to this file. And it's just making sure that this file's code does what we expect it to. So when you run React scripts test, it's going to try and test your code. And it'll tell you whether or not your code is doing what you expect it to do according to the test. If it doesn't, it will break and fail. And again, we're going to talk about testing much later. I don't want to bog you down into the details of it right now, but just understand that's what this does. Now, finally, let's talk about eject. To talk about eject, we have to get a deeper understanding of actually what happens in the build. So one thing I want you to think about is that when it comes to a browser, right now I'm using Chrome, but there's actually numerous different browsers. There's Safari, there is Internet Explorer, there's Edge, there's Opera, there's probably some other browsers. Each browser is implemented a little differently. That's why there are different browsers. What this means is that they consume the HTML, CSS, and JavaScript files in their own way under the hood. This code that we're writing, which is React code, is not necessarily code that every browser can understand. A lot of the times, this is some interesting, funky syntax, which we'll deep dive into once we go throughout the course, that is already kind of hard for us to understand. We have to understand how React works in order to write this code. The browser definitely doesn't understand. Oftentimes, the browser understands an older version of JavaScript syntax only. So what's happening is that in this build process, there is actually two libraries being used, or two packages, two helpers, essentially. One is called Babel, and the other is called Webpack. What Babel does is it takes all of this React code that we've written, all this React funky JavaScript, and it actually condenses it down into this JavaScript that these browsers can understand. If you look at it, it's very basic JavaScript. Very, very old school JavaScript. None of the new syntax that you and I are used to writing with. So the reason for this is because, again, all of these browsers, all these different browsers can understand probably a very basic version of JavaScript. And Babel is just making sure that all of our code gets built into a version that can be understood by these browsers. So I mentioned there were two main helpers. There's Babel and there's Webpack. What is Webpack? Well, Webpack is actually something that makes our code a little bit more efficient. So inside of here, this index.html, there is some JavaScript that is focused on actually pulling the primary JavaScript files. So inside of the static folder inside of build, you'll see there's a CSS folder, there's a JS folder. Inside of this JS folder is all the different chunks. You'll notice that they all end in this .chunk. A chunk is essentially a contained portion of JavaScript code that is working together to actually represent a part of our application. What it's doing is that Webpack is saying, hey, sometimes, let's say our application, we wrote a massive, massive web page. There's a lot of different JavaScript files that even when reduced can only be reduced so far. So what Webpack says is, oh, okay, actually, you know what? Let me break these into chunks so that when the user is trying to access the homepage, he just gets the JavaScript related to the homepage. If he wants to navigate to like another page, then I'm going to turn that other page into a new chunk and then send it to them when they need it. So Webpack is essentially modularizing our code. Module being a chunk. That's a good way to think about it. So that's really what Webpack does, is it's saying, oh, your JavaScript's really big. I'm going to make sure that I optimize it and break it into the self-contained portions of it so that when the user is trying to access one part of it, it only gets the relevant JavaScript for that part. It's not going to get all of it. And that's all Webpack is doing. So essentially, what Build is doing is it's leveraging Babel and Webpack in order for it to properly optimize for these browsers as well as for the speed so that we send down all the appropriate chunks when the user needs them. That's what it's doing. So how does this relate to what I was talking about, which is eject? Well, again, Webpack and Babel are tools. That means that you can modify them so that they follow some specific rules that you want. Create React App is just saying, hey, I've already optimized that for you. I'm optimizing telling Babel and telling Webpack what to do. If you want to modify it for your project needs and concerns, you can eject. And what that will do is it will spit out the files that are related to actually showing you what Babel and Webpack do. So you can modify them to do what you want. And actually, Andre is going to break that down in the next video and actually tell you why you shouldn't eject, because honestly, Facebook's a really optimized team for this kind of stuff, and they've written extensively and they've tested extensively the best configuration for Webpack and Babel for most cases. Chances are you might actually work on a project that does need you to eject because of some funky work requirement based on your project. But most of the time, especially for us learning React, we definitely don't need to eject. But that's really what's happening here. Now, before we break down some of the core portions of the actual React code, I want to take a look at a couple other of the more minor files that we got generated. There is this setup tests.js, which is related to the actual tests themselves. It's just a file that really just imports the specific testing library. And that testing library will dive deeper later, so don't worry about this one. Inside of our public, there is a favicon. So this favicon is really just this icon right here in the tab of your browser. That's just what that icon is. We also get these logos of these different sizes, and these logos are more so related to this manifest.json file. The manifest.json file is a way for us to actually be progressive web app compliant, and all this means progressive web app is that some people want to be able to download your web application onto their desktop so that they can access it offline. It's essentially a way for somebody to use your application not through the browser. So essentially with these logos, you can create this little icon of your choice, which is what these logos will be, inside of this contained progressive web app application that they download from the website onto their desktop. And then that logo is what they double click to actually open your progressive web app version of your website. If that seems confusing, don't worry. We're going to go through how that all works later, much later in the course, but just understand that this is doing that for us. And then there's also this robots.txt file, and this file is just telling essentially web scrapers, which is SEO related. So like Google, for example, when they determine whether they need to rank your website higher or lower, it crawls your website with their own kind of like code crawlers. And this robots.txt is just a way to help explain what that is. This one you don't have to really worry about as far as your building web application goes, but just understand that it's generated for you. So now that we understand the majority of some of the lesser important files that are all generated for us, we are going to dive into what the main bulk of the actual code created for us by Create React App and related to React code is related. And we're going to do that in the next video. So I'll see you in the next video. Welcome back, everyone. In the last video, we took a look at what files and folders got built for us by Create React App. And inside of package.json, we took a look at our start script. We took a look at also the files related to setting up the initial project, which is the index.js file and the index.html file, and how React DOM at a high level helps us render out our application. In this video, we are going to deep dive into the 3 remaining scripts inside of React. And what we're going to do as well is we will take a look at some of these other files and how they relate to these scripts. So diving into the next one, which is build. What is build? So right now, what I want you to understand is that when we ran script start, this is just taking our application code and pushing it directly through our local port of 3000, so on our computer, and our browser is just accessing it directly. It doesn't have to go through our network, which is our Wi-Fi or internet connection or anything like that, in order to get the related files in order to run our application. It doesn't need to. It's all local on our computer. So this is incredibly efficient and fast. We don't even need to think about optimizing it at all. But when we're actually hosting our application live somewhere so that anybody can access our website, they need to leverage their internet connection. And as we know, internet connection varies and it can be very slow. So what needs to happen is our code needs to be much more optimized so that it's as small and efficiently served as possible. And that's really what this build step does. So going back to our terminal, if we do something like we call yarn or npm, whichever one you prefer once again, and we call build, what will happen is that React scripts will actually generate an optimal build for us, an optimal build folder. And what this is doing is it is taking all of this code that we have. So all of these separate files and all of these different JavaScript and CSS files. And what it'll do is it'll actually group it all into one file for each related JS, CSS, index HTML, and it will make it as optimal as possible. And it will put it all inside of a new folder right here called build. So if you go into this, what you'll see is that there's our index.html file again. But inside of here, you see that it's very condensed. And what you'll notice is that in here is all of the code related to our application. You'll see that there's all this like really funky looking JavaScript code, and it's really tight, and it's just using these very reduced variable names. And the reason for this is because it's trying to create the most optimal low memory version of our application as possible. So that's really what's happening here. It's taking all of these files that we have, all these potential JavaScript files that we're going to write throughout this course, and it's just condensing it down into the fastest version that can be sent over an internet connection for a browser to consume. So that's really all this build is doing for us. So going back to our package.json, we want to look at test. So testing we're going to cover extensively later in the course. At a high level, all you need to know is that tests are just ways for us to make sure that the code that we write for our React application does what we expect it to. Inside, you'll see that there is a app.test file. Don't look at the content for now. This is not as important right now. But essentially what it is that it's a test file that is trying to test something in specific. In this particular case, it's testing the app.js file. We haven't looked at these yet, but all you need to know at a high level is that this test is related to this file. And it's just making sure that this file's code does what we expect it to. So when you run React scripts test, it's going to try and test your code. And it'll tell you whether or not your code is doing what you expect it to do according to the test. If it doesn't, it will break and fail. And again, we're going to talk about testing much later. I don't want to bog you down into the details of it right now, but just understand that's what this does. Now, finally, let's talk about eject. To talk about eject, we have to get a deeper understanding of actually what happens in the build. So one thing I want you to think about is that when it comes to a browser, right now I'm using Chrome, but there's actually numerous different browsers. There's Safari, there is Internet Explorer, there's Edge, there's Opera, there's probably some other browsers. Each browser is implemented a little differently. That's why there are different browsers. What this means is that they consume the HTML, CSS, and JavaScript files in their own way under the hood. This code that we're writing, which is React code, is not necessarily code that every browser can understand. A lot of the times, this is some interesting, funky syntax, which we'll deep dive into once we go throughout the course, that is already kind of hard for us to understand. We have to understand how React works in order to write this code. The browser definitely doesn't understand. Oftentimes, the browser understands an older version of JavaScript syntax only. So what's happening is that in this build process, there is actually two libraries being used, or two packages, two helpers, essentially. One is called Babel, and the other is called Webpack. What Babel does is it takes all of this React code that we've written, all this React funky JavaScript, and it actually condenses it down into this JavaScript that these browsers can understand. If you look at it, it's very basic JavaScript, very, very old school JavaScript. None of the new syntax that you and I are used to writing with. So the reason for this is because, again, all of these browsers, all these different browsers can understand probably a very basic version of JavaScript. And Babel is just making sure that all of our code gets built into a version that can be understood by these browsers. So I mentioned there were two main helpers. There's Babel and there's Webpack. What is Webpack? Well, Webpack is actually something that makes our code a little bit more efficient. So inside of here, this index.html, there is some JavaScript that is focused on actually pulling the primary JavaScript files. So inside of the static folder inside of build, you'll see there's a CSS folder, there's a JS folder. Inside of this JS folder is all the different chunks. You'll notice that they all end in this .chunk. A chunk is essentially a contained portion of JavaScript code that is working together to actually represent a part of our application. What it's doing is that Webpack is saying, hey, sometimes, let's say our application, we wrote a massive, massive web page. There's a lot of different JavaScript files that even when reduced can only be reduced so far. So what Webpack says is, oh, okay, actually, you know what? Let me break these into chunks so that when the user is trying to access the homepage, he just gets the JavaScript related to the homepage. If he wants to navigate to like another page, then I'm going to turn that other page into a new chunk and then send it to them when they need it. So Webpack is essentially modularizing our code. Module being a chunk. That's a good way to think about it. So that's really what Webpack does, is it's saying, oh, your JavaScript's really big. I'm going to make sure that I optimize it and break it into the self-contained portions of it so that when the user is trying to access one part of it, it only gets the relevant JavaScript for that part. It's not going to get all of it. And that's all Webpack is doing. So essentially, what Build is doing is it's leveraging Babel and Webpack in order for it to properly optimize for these browsers as well as for the speed so that we send down all the appropriate chunks when the user needs them. That's what it's doing. So how does this relate to what I was talking about, which is eject? Well, again, Webpack and Babel are tools. That means that you can modify them so that they follow some specific rules that you want. Create React App is just saying, hey, I've already optimized that for you. I'm optimizing telling Babel and telling Webpack what to do. If you want to modify it for your project needs and concerns, you can eject. And what that will do is it will spit out the files that are related to actually showing you what Babel and Webpack do. So you can modify them to do what you want. And actually, Andre is going to break that down in the next video and actually tell you why you shouldn't eject, because honestly, Facebook's a really optimized team for this kind of stuff, and they've written extensively and they've tested extensively the best configuration for Webpack and Babel for most cases. Chances are you might actually work on a project that does need you to eject because of some funky work requirement based on your project. But most of the time, especially for us learning React, we definitely don't need to eject. But that's really what's happening here. Now, before we break down some of the core portions of the actual React code, I want to take a look at a couple other of the more minor files that we got generated. There is this setup tests.js, which is related to the actual tests themselves. It's just a file that really just imports the specific testing library. And that testing library will dive deeper later, so don't worry about this one. Inside of our public, there is a favicon. So this favicon is really just this icon right here in the tab of your browser. That's just what that icon is. We also get these logos of these different sizes, and these logos are more so related to this manifest.json file. The manifest.json file is a way for us to actually be progressive web app compliant, and all this means progressive web app is that some people want to be able to download your web application onto their desktop so that they can access it offline. It's essentially a way for somebody to use your application not through the browser. So essentially with these logos, you can create this little icon of your choice, which is what these logos will be, inside of this contain progressive web app application that they download from the website onto their desktop. And then that logo is what they double click to actually open your progressive web app version of your website. If that seems confusing, don't worry. We're going to go through how that all works later, much later in the course, but just understand that this is doing that for us. And then there's also this robots.txt file, and this file is just telling essentially web scrapers, which is SEO related. So like Google, for example, when they determine whether they need to rank your website higher or lower, it crawls your website with their own kind of like code crawlers. And this robots.txt is just a way to help explain what that is. This one you don't have to really worry about as far as your building web application goes, but just understand that it's generated for you. So now that we understand the majority of some of the lesser important files that are all generated for us, we are going to dive into what the main bulk of the actual code created for us by Create React App and related to React code is related. And we're going to do that in the next video. So I'll see you in the next video. Welcome back, everyone. In this video, we are going to dive into the meat of the actual React code finally. So what we're going to do is we're looking at the app.js file. As I mentioned, the app.js file, if you think back to our index.js file, we were importing app from this .app file. So app here is actually the app.js. And what app.js is it represents our entire React application. So we're going to dive deep into how this one file doesn't actually contain the entire application as we build it out. It's just that right now, this is the main bulk of what the application represents. Because the application is very simple. It's pretty much just this part of the website. So if you look at it, all it is with React is that we are importing the logo, which is the logo.svg. And we are also importing our app.css file. So this is also generated for us, and it's what makes the logo spin and gives the background color and then makes these the certain sizes that they are. That's all this CSS that's listed in here. So by importing it, we're saying, oh, I want you to apply the CSS. So that's being applied to this website now. Here, you'll notice that there is this function. And this is very important because in React is pretty much just using functions to return HTML. That's all it is. This code is just some generic function called app that returns you this specific HTML that represents this function of app. And you can see this app function as a component. So what is a component? A component is pretty much a self-contained piece of code that returns some visual UI representation of HTML. UI being this thing that we can see and interact with. Now, as we know with websites, anything we interact with is a combination of HTML, CSS, and JavaScript. So this is no different here. It's just that all of this is contained within this function. So inside of here, if you look at this is pretty much just basic HTML. We have a div, we have a header, We have an image, and this image is being passed the source of our logo. So our logo, SVG, which is just this icon that is spinning. And this image is being rendered inside of this header HTML component. And then there's some p tag here with some text inside. And then there's an anchor tag that points to Learn React. Very simple HTML. And this function is essentially returning this HTML. So that's really all that's happening, is that inside of index.js, React is just saying, oh, I want you to render this app. And here, this looks like an HTML tag. And the reason for that is because using React DOM, we're saying, oh, okay, this HTML tag is some function code that will return us more HTML, which is exactly what app.js is. It's returning us HTML code. So what we're looking at here is really just the HTML that's being rendered on the page. And if we update this, let's say I update this p tag to say, hello, my name is Yihua. If I save this, now if I go back here, again, Create React App is just rebuilding, and it is updating this text now to say, hello, my name is Yihua. You saw it's pretty automatic. But here, what we're just seeing is that that's really all React is, really. It's just code, so a function or a class, which we'll learn about later, that returns us back HTML. That's really all React is, if you really want to think about the very bare bones of React. It's just these helper functions that help us return HTML. So it allows us to build websites and these UI in a very efficient, componentized way. Components, once again, being the self-contained representations of HTML, CSS, and JavaScript. So this is really all that's happening here. So with that, you pretty much understand actually all that React App has given us. Some of the more nuanced things that go on, such as tests and the progressive web app stuff, we'll explain later. But as far as the main bulk of what we're going to work on, when we start converting this Create React App application over to the Monster Rolodex project, is just going to be around writing these functions or these classes that return us back HTML. And that's all it is. So now that you understand what Create React App does, there is one caveat I must mention before moving forward. So a lot of the videos were done using an older version of Create React App. Right now, I'm actually speaking to you in the present with the latest version of Create React App. So when you go through, you'll notice that some of these files are slightly different, but honestly, it's so insignificant. It's pretty much all the exact same. It's just that a couple things have been tweaked and the placements are a little different, but all the concepts you learn and everything that you see is going to largely remain the same. So definitely don't get scared if you see it. Just understand that all the core concepts that you have are already now fully explained as to what Create React App is doing. The older versions are doing the exact same thing. It's just that Create React App and Facebook like to change the way that they build things every once in a while. Not necessarily because it's more optimized, but sometimes just because they want to introduce some things or remove some things, but nothing is that significant. 99% of everything is largely the exact same. So now that you understand this, let's start actually building out our Monsters Rolodex project and getting really into the meat of our React application. So before we start doing that, once again, Andre is going to just quickly dive into why you should not eject by showing you what happens when you eject. Once again, this is just a better understanding of what it is that our code is doing. But here, again, you understand that all React is just functions that return HTML. That's really all it is. So with that, let's move to the next video.
Hey, welcome back. I just want to add a quick note here. I have actually ejected a Create React app just to show you what happens. You will see here that it gives me a folder called scripts and then a folder called config. And in here, well, this was everything that the creator React eject up while heading unseen from. You had things like just that was using for we have our web configuration. Remember our modular bundle. You can just over here how long it takes, complicated it looks. We also have all the scripts that were run. For example, then we can run npm run build or npm run start or test. You see over here that just quite a lot of code. This is why I recommend not ejecting, because no matter what, no matter how much time you spend with it, you're never going to compete with the developers that are working full time trying to make create React have the best tool possible. Developers that are getting paid to make this tool as easy and as efficient for you. So I recommend that you never eject out of a reactor unless you absolutely have to, because by using Create Reactor, you automatically get the best system and project it out of the box. And anytime there are updates or the industry changes and there's new ways of doing things, Create React app is automatically going to have a new version that has those changes implemented by professionals. So again, I wanted to show you that this is what's happening underneath the hood. But 99.9% of the time you don't really need to check because you lose all the benefits or React gets more and more updates. We know that we can write functions that return HTML, but we can also write classes that return HTML. And the reason why we would want to use a class is because React has given us the ability to write classes that have a lot more functionality on them versus a function that returns some HTML. Now let me show you this. So in order to write a class, we have got a first import, and instead of this function app, I am going to convert this into a class. So class app extends this uh, component that we get from React, and as a result we now have access to this render method inside of our app class, and the render method returns anytime I want. So let's return that HTML we had before inside of our function, and we will see that it's actually the same. And to prove it, I'm going to change this to this text here, and we should see an update hello Java. So this is great. So it's pretty much the exact same at this point as our functional component, functional app that we had before, right? Our function app that return this block of HTML. But the reason why we would want to use this kind of thing is if we wanted, say, instead to display this static string hello Viha, and something like, let's say, instead of an tag dog, we had a button. And whenever you click this button, it would change the text to something else, right? We would change this hello world. This thing about this is that by using a class component, we actually get access to this thing, because this thing is called state. What state is it? Is some object, right? A JavaScript object with properties that we can access at any uh, point inside of our class. And the way we would do this is we would actually call the constructor keyword here. And inside of a constructor, we want to call super, uh, and that super method on the component class we use. And what that does, it gives us access to this state. This state property now exists on our class app, and we can set it to something. So this is the default value. I want to set it to first. So let's say I want to set it to the string that we have right now. I want to set some property on our state object to hello Yuvaha, and then I want to render that instead of hello the static string. How would I do that? Well, I would first use these curly braces, which let's do and test the start that anything between these curly braces is going to be JavaScript. So I want you to render JavaScript, right? So we want to do this dot state dot string, and now between these p tags we actually don't see anything, because uh, just to prove it, I'm going to show you. You are saying that where we see that it's looking at the state, looking at this property string, and rendering that here instead. So that's awesome because how I can do this in multiple places, right? I can use this as many times as I want, and I'm going to see this right now. And what if I wanted to change this value? While the way I would do it, this class as that extends component. This component also gives us this method called setState. And what sets it does is it lets us modify this state object right on every single HTML elements. We now have access to this method, this property called onClick, which takes a function that gets called whenever this element gets clicked. So let's pass in this function, and in this function we are going to say this dot set state. And what set state takes is an object with all of these properties that you want to change on your state, as well as the new values that you want. So I want to change the property string to hello Henry. Now when I click this button, we see that it's changed, right? And that's really awesome because this gives us a lot of control over what we want our component to display. So this will be really very useful later when we don't know where we are going to get some of the information that we actually want to display inside of our HTML. But I'm going to show you in the next lesson why this is really useful. Hey there, it's Henry. I wanted to add a quick note, a few things that you may have to think about. You may be asking why we changed this from a function to a class and older versions of React. I actually started the app with a class instead of a function. Now this topic of classes versus function is something that we are going to cover more and more in depth as we get through this course, and especially toward the end when we talk about React hooks. Know to go through this code, we need to understand a few things. The very first thing is that this syntax of return, which we are going to talk a little bit more about syntax of JSX, but for now it's look like everything is just an HTML thing. However, because this is a JavaScript, there is a few changes, and one is that this class name over here, that's not HTML, is it? And if I hover over there, you see that it's a JSX attribute. You see, because if I use this word class in here, class means something else in JavaScript. It means when we are creating a class, right? So here use the syntax of class name to distinguish between what we actually mean. What is actually giving it an HTML class versus a class in JavaScript. Other thing, we are these brackets over here. You see how every time we write these curly brackets, and inside of our JSX format, well, they mean inside of here, anytime you see these curly brackets, whatever inside is a JavaScript. Okay. So what does that mean? Well, logo is a variable which is the logo that we import this dot state dot string. Well, that's also a variable which is referring to the state. It's a JavaScript expression. It's something that produces a result. For example, I could have done 4 plus 5 here if I wanted to, because it's a JavaScript expression. Another place that we see this is right here with the click again. Anything around these brackets is a JavaScript expression. So what in here? There is a function, right, an asynchronous function using this arrow syntax that simply calls this dot set state. Now notice here how we don't actually modify this set state like this. This dot set state. do string to equal something like as like we would normally and this goes back to the idea that I mentioned previously, which is this need directional data flow of React. You see, you are not allowed to modify state in React without calling this method setState. Now, why is that? Because anytime we change the state, let's say a user clicks that button to change the state to a new string, when that click happens, what happens is React actually intercepts, because remember, React is one that's taking to this, it's going to intercept that click and it's going to report back this. Okay, well, in this case, what we are going to say is on click, when we click happens. I want you to update the state, but we are not going to modify the state automatically. I'm going to say, hey, a click happened. State gets updated using state, and then that change is going to be re-render the component so that we can go through this flow again. If we look over here, as soon as this state gets called, which is when a click happens, well, what's going to happen? This render method gets called again. Why does it get called? Well, because state just got state now is different thing. And remember, the declarative approach with the React is that as soon as state changes, we are render the component with the new state, which is right here, and we display that. Now this on click is that, well, if I hover over here, it says no, that is a JSX attribute. Again, remember, this is not HTML. We are just things. And if I wanted to say use on click in HTML, you see that on click is this like this, no capital C here, because in JavaScript we use camel case. It's a just capital C. So just like class name different in HTML, different in JavaScript. On click is also different. So in React we can use whatever attribute that we want, like source, like class, like on click. But sometimes there's these differences like class name or on click. Now we are going to explore these different attributes on click, but the key thing to remember is that JSON JSX is trying to mimic that HTML, that so that keep getting create that virtual DOM and break down each part of the app into these components that keep getting re-rendered as we update the state using set state. Let's keep going. Now let's start making our application resemble more closely to our actual final monstrous Rolodex application. So we know that we need to display a list of monsters. So instead of the string hello Yuva, I am going to make a new property called monsters, and I am going to make it an array of objects that have a name on it. That's the string value. So our first monster will be Frankenstein, our second monster will be Dracula, and our third monster will be zombie. So here I want to render, let's say, just a bunch of ones with the actual names of these monsters, right? So how I would go about doing that is I'm going to go right to this render method, and we write our curly braces because we have got to render some JavaScript, right? So now between these curly braces, we can really render any JavaScript that we can. So here, so I am going to tell all the state.monsters.map, because map returns us the return of whatever function we pass to. It iterated over every element in the array, in this array. So when I say iterate, what I mean is that this function what I write here, whatever this returns, it's going to return in the place of every element in this array. So I'm going to call map on this monster array, and map takes a function where the first argument is going to be the actual element. That this function is going to get called on, right? So it's going to call the function we pass in on it on Frankenstein, and then on Dracula, and that zombie, it's going to call it on each object. Now, what that function returns will be what gets returned out of this step. Usually, it's a new array, right? When you call it, but React is smart enough to know that if we end up rendering out a bunch of HTML blocks, that array, then it will just display those elements. So let's take a look. So our first elements, right, our first argument is monster. So I'm going to return a new one. But each one where I am going to again call the curly braces, because this is a new return block, right, of TML. Just like this, it's going to need new curly braces, and inside I am going to call monster name. Now what we should see is the name of each of our monster, right? We see that now if we open up our console, we'll see this warning that says each child in a list should have a unique method. So it's asking us to add a unique key to every child that gets returned out of this map, right? We got to provide something that is unique completely to this list of elements, right? So let's just make our value of ID and just call it something like this, right? On any random unique string, well, work, and the reason why we want a unique key is because React needs to know what element it needs to update if one of these elements in our array has a value that changes, right? Now let's say, for example, the user does something and it changes the name of our app monster from Frankenstein to Vinci, for example, right? Like say does it in the code somewhere, Vinci, like the same way that we saw when we call the monster. Well, React is smart enough to know that it only needs to update that first one, right? To change it to that the new props, it doesn't need to re-render all of these, and the key helps React understand. It helps it know which element is the one that's been updated, right? Which is attached to which element, so that it knows that it doesn't have to render everything. You can see how if this list was very bigger, it would be really performant heavy to render all everything. And that's what makes React so great. It's that it's smart. It knows that if only one element in a list of 1,000 element changes, it only needs to re-render the part of the HTML that matters, not the whole thing. So now that we have our list, we actually want to make this look closer to the final. So right now, these are just placeholder for us to understand a little bit more to write React, we're iterating over an array and creating new elements. But let's actually dive a little deeper into it. Welcome back. In this video, we are going to start talking about something called life cycle methods. And now, in order to prepare for that lesson, I want to go over something that we already saw. This component class app extends components. Now, what does that really mean, component? If we look here is part of the React library, and we are using distraction structuring here. But if I didn't include it like this, I could still use it the React dot component, because component well is a property on React that we can use. And when we do something like class app extends React component, what we are doing is saying, hey, I want whatever functionality that this really component that was already built into the library by somebody. I want the functionality and I am going to add on to it. So for example, this render method comes built in with the React component, and this component gives us some batteries including option to use in our component, so that we don't have to constantly repeat ourselves. We use something that really says, hey, this is this, and we just track on some specific functionality to it. As you will see, we learned about cycle methods and how these components have some important things already on them, such as if I type in system here, you will see that I have some methods that uh, comes from the React component wrap cycle. But we will get to that shortly. Another thing I want to talk about is this idea of an API. Remember how we talked about the birth of the single page application? How initially all we had to do with a normal web page was we visited a link and we got the JavaScript. When we clicked on another link, we went to a different thing. So we got a whole new HTML JavaScript access file. However, with single page application, we now have this idea of communicating with the back end initially, where we get a tiny email page. Remember, with our just idea of route we fill in our component, and then we have this massive JavaScript file, or at least bigger than he usually was with our React library, with our components, with any of our logic. So now, instead of having to communicate back and forth with the server, if I click on something, let's say visit a different part of the page, I don't have this. I can just have JavaScript or React say, hey, just re-render the DOM with something else. So now with a single page application, instead of requesting a page, it's turned more into requesting for data. And this is when we have the ability to, let's say, communicate with outside servers, maybe servers that we don't control. For example, in our big project, we are going to talk to the Google Firebase database. We might talk to some different API endpoints, so that now we can communicate with different APIs back and forth, and using JavaScript just receive the data. For example, we saw that this JSON placeholder website, by entering into this website, all I get is, well, not an email page, right? All I get is this data that is formatted in what we call JSON. So this JSON data can be converted into, let's say, a JavaScript object that we can use. But all this does is provide us an API, a way for us to access information from, well, this server. So they are now single page application. Instead of just rendering, HTML can use this data to perhaps display different monsters, different to user information. And as we all see, it will allow us to do interesting things like sign in, sign out, add items to the shopping cart, and we will explore that idea throughout this course. And by the way, there is a way for you to actually check this. If we open up our developer mode, we go to network and I refresh the page. Here you will see that I have this users document. If I click on it and if I go to response, we see that this is the response that we get. So as you started to build larger and larger application, what you will find is that you will start talking to APIs and trying to get different data for your application. And these endpoints or servers that we speak to can be third-party servers like Google servers, or they can be your own server where you perhaps have your own database. Now that's something that we are exploring a little bit more about this, but the key thing is that the way we build application now is very dynamic. Most of the time we don't have to code all the information into this. Instead, when a user opens something, we are always communicating with outside server. So we are going to start structuring our app this way. So we just learn how to take an array on our state and turn it into elements that we can then see right now in a real world scenario. We are probably not going to hard code the information that we are going to have, right? Normally we would probably get it from a backend of some kind of server and some kind of database. So I am going to show you how that would actually work. Now luckily I have a pretty good resources where it will give us a sample of 10 users, right? Without us having to actually build a backend server of some kind. And it's at this link. It will give us back is the array of these objects, right, that have these properties like ID and name and email on it that we will use for our application. So what we need to figure out is how do we get this app component to make a call to the backend and then put that data into our state so that our render function knows to use it right now, can have access to it. So how do we do that? You see, you remember how we got the render method by extending into component. We also get a bunch of other methods that are called lifecycle methods. What are lifecycle methods? Well, if we look at this here, we see a list of all these methods and it's an overwhelming list. But what lifecycle methods are is they are essentially methods that get called at different stages of when this component gets rendered. Now I know that kind of jargon right now, but I am going to explain it to you throughout this course. But the main one I want us to focus on is component mount. Now, what component did mount does it? It's kind of like the name, right? When the component mounting is essentially one React puts our component on the page, right? It's render it onto the DOM. When it does that, it calls whatever block of code we write inside of here. That's all it does. So what we want to do is we want to use JavaScript native fetch, right, to fetch from that URL, make an API request to that your URL, and what this fetch returns us is a promise, right? But that promise uh, gives us response of the actual body of our response, but we don't know what that looks like at first. So let's just log it out, and so we see this response object, right? It's got the body and it's got these headers. It's got all these properties that we don't know right then. The main thing we want is we want the body, but we want it in a format of JSON. So let's from here return response JSON, which is the method right on the response object that will give us back that response in the JSON format, which we and then that will get returned to us as a new promise, which we will now have as a body, which will be this array. So when we get that array, let's just log it again so that we know what that means. We see or are right in the format in the object that we have. And we can use, so what we want to do is now we want to call set state as we did before, but now we want to set our monsters to this array of these users, right? And we want our initial state to be an empty array because we don't need to hard code it anymore, right? We are going to wait for our component to mount, and then we are going to fetch our array of our users, and then we are going to update our states monster property with this new array of users. And now when we check our application, we see that we have all of our monsters or users, right? And we are displaying all their names. Now we see this area here, right? It's just a warning logo anymore, so let's just get it. That's the great thing about Create React App as well. We can be aware of writing and making our code clean. So now just to go over this again, we are using this component with mount lifecycle method that we have access to because of our class component. And we are fetching from this new URL, we are taking the response and converting it into the JSON format that our JavaScript can understand and use, and then we are going to take the users that we got back from it and set our monsters to that array of users. And that's how we end up with the with this list of users. In the next section, we are going to now convert this to look a little bit closer to this. Now, before we get into the next section where we are going to build some of these components and start making our app, I want to go to our thing. You notice here that we are rendering this app, which is HTML, but our own custom components. We are importing this app file, which is app logs, and then this is something that we are going to write later on. But we see over here that we are returning under the render some estimate. Now the way React works is that we can combine these HTML-like elements such as div, h1, but also create our own custom ones like we will like search box or cart list. And just like we saw on our developer tools with React, these components we have capital letters. And I have used some highlighting things. You can see the difference between a component that we build, which starts with the capital letter, and a component that comes pre-built and React, which are like a dev, division, or h1 tag. These are lower cases. And as you remember, with the React component architecture, all we are doing is just creating and these Lego blocks things, and the syntax is either using the classes syntax with a capital letter. So now we can use the app component, or if we go to something like search box or card list to search box again, but we will build them over and next thing. You will see that here I have a different way of building a component, and this uses just an arrow function. So remember when we first did the create React app, now search box, or in our case we had the app, that in here we return some like h1. Well, this is the same thing except that we are using an arrow function way. There's two ways like this of creating component, the class component and the functional component. Now that's something that we are going to go into a lot because it's an important concept and has some implications, but we are getting ahead of ourselves. The key here is to realize that we have for now two ways of building components, either just as function like this, again using capital naming system, or using classes like this. And both of these, no matter what, always return some sort of for us some sort of React elements. Now, another thing I want to mention is the folder structure that we are going to build throughout our course, and a good folder structure is really, really important on any project. As projects get bigger and bigger, as we get more and more JavaScript files, things are going to get complicated. So we need to be organized. So we are going to be structuring our app like a lot of professional reactive helpers are so that they stay organized. And what you will notice here is that Iguha, when creating components like this is if a component in this component folder has JSX in it, he actually ends with the file with .jsx, and you see we have this icon. If I go down to the bottom over here, you see that this is the thing. So just simply means it's a JavaScript, but with this syntax. Now, if I change this to a simple JavaScript file, it's still going to work. It's why AppLogs still works the way it does. And this is actually just personal preference. This is how Ecoha enjoys organizing this code. This right way I can look at it and say on this is a React JavaScript or JSX file. But at the end of the day, remember, React takes everything into this, actually convert this file into a JavaScript file. JSX convert into JavaScript file. So whether you do JSX or JS, that is same. Maybe your editor will help you with these things. It's just personal preference. It's all about structuring your application in a way that's easy to understand, that makes sense. Even the naming convention here is important, where again, just by looking at the file, even though it's in the components folder, right away, I know, oh, this is a component and this is the style for the component. And now these styles, these access files that we are going to be writing, and trust me, we are going to be writing a lot of them. At the end of the day, what happens underneath the hood is that create that combines everything all together. And if you remember, if we go back to our test folder, then we run npm run build and go to the file. You see over here that we have a chunk, of course, with a map. This is a source map which just helps us debug our code and things. But we have just one massive file, and that's what we racked up. Done. Even though we will have different access files in our workspace, in our source folder, together of the day, when we release to production, all of these are going to get combined together. And although we are still early in the course, although we have not really built our things, I want you to start noticing these things. As we build things, we are going to be thinking about how to stay organized instead of just having all the files in one directory, instead of not having any organization. Right, from the beginning of the project, we are starting to think about these things, and this is an important principle that we are going to take with us throughout the rest of the course. Let's keep. Okay, so now we are going to start converting our current application to look more like the final application. Before we do that, we have got to take a look at this idea of component. So right now we do know that our only component is the app component. We have only written this one single class based component, which is our app. However, in React, what we want to do is we want to be able to break our code into smaller reusable pieces that are only focused on one responsibility. So when we look at this, we see that this card seems to be its own component. This search bar is its own component. And in a way, because the card is itself, it does not really care about the other cards around it. So there's a got to be something that seems to be containing every single card on our page. And that is going to be another component. Now, when we build that outside wrapping component, we are going to actually take a deeper look into what components are in React. So let's first make a components folder, and inside we will make a card list folder, and in that card list folder we are going to make a card list component. Now you don't need this component part, but I like to add it just so that I can tell right kind of file that is it. So this is our component file, and we need to import React from React, and we are going to export out this card list, right? And it's going to be a functional component. And what we want to display for now is just the containing div. Now, one of the big things about components is that they take something called props, and props is uh, going to be the parameter that we get from our functional component. So right now, let's just log this out and see what this looks like, because it's important for us to know what props actually are. And inside of the div, I am just going to put hello for now. And let's consult logout props. So now we know that we are logging it out when we put it our and import it into our app file. Import component card list component. Now let's just put this above here for now, and let's not put anything it is. Now you remember earlier when I said that there are these props parameters, right? This is actually going to be any parameter that we pass into card list. So if here we say there is a prop called name, and we pass in you, that will actually log out when we look at our app. Is this card list that says name, right? And then it says Yuha. So right there is our card list component, and right here you see that we are logging out Yuha, right? So that prop is going to be an object of any property that you write on to this component and get seen. Now generally speaking, of course, we want the props that we are actually going to pass in, the parameter that we are actually going to use inside of our component. But one of the main properties that exist on this props object is one called children. It will always be there, but if there no children, so what are children? Children are actually what you pass in between the brackets of our component that gets called. So if in here I say Yuvaha, then the children props will be this Yuvaha, right? Actually, I am even going to make it an H1 just so that I can show that it's anything in between these tags. So now if we instead render props to children, got to remember to use the squarely brackets, because that tells that we are going to use JavaScript, and now we see Iwaha, and this is an H1 as well. So that's one of the big things about props and components. We actually have access to props as well. On our app component, on the this keyword, it gets attached to our actual class as a prop, and if we want to access that, we would use this thing, but because we are not using it yet, there is no reason to this. But in a later lesson we will actually see what that is. But for now, let's just focus on our card list. So we are adding in these props, right? We are passing the children because we do want that, and then we are going to actually do some of the styling to make it look more like this. So we noticed that this is in kind of like a 4-column grid. Well, I actually have some of the CSS written already for us that you guys applying here, but I don't want to focus too much on the success because it might be a little things and about when we are trying to learn right things. But there is one thing I want to highlight. So first, let's make a card list styles. Okay, and let's add that in. So all I am saying really quickly is that I'm using the new CSS grid. I'm setting the display to grid. I'm saying that I want the grid to make everything fit within 4 of these columns, each one being the size of one fraction, which is essentially an equal part of the overall size of what the width of this card list will be. So there are just 4 equal columns, and then between each column there will be a 26. Let's use that. So let's important that in, and then let's put it on. So let's get rid of this for now and let's put it on to our class name. Class name will be called, if we save it, we will see. Now that he was in here, right? But we want everything in there as well. So now instead of passing, you have throw. I want to pass all of our monsters through, right? So again, this map is going to generate our list of those ones the same way, but then it's going to put it as the children in between this div that we have as our card list component. And now if we look, we see that it's an unequal grid of 4 equal columns. So this is a really fundamental thing about React is that we are just building component that only care about one thing, and our card list component only cares about displaying card inside of it in some kind of configuration. Right now, the next thing we are going to look at in the next lesson to take that idea a step further, and we are going to applying it to this card to components. Hey, now that we know what to do with our card list component, we can actually take it a step further. So earlier we were just passing children in and rendering it between our outside division, but we don't actually want to do that because right now our app component is actually the one that is currently responsible for mapping over that list of monsters and then creating those elements. But we actually want to give that responsibility to the list component because the card list component should be the one responsible for listing the cards. So let's actually move this into it. So first, what we are going to do is we actually don't need this anymore. This is completely unnecessary. We are going to pass in the monsters as a prop from our app component. And then we are going to move this into the card list. So we know that we don't need the children anymore. Instead, we are going to generate it ourselves, and it's not off state, it's off the props. So if we do this, everything should stay the same, which it does, which is awesome because now our app does not have to worry about creating those monster cards, right? The cardless component is the one that's responsible for it, which is great because it's the responsibility of the cardless component. But what the cardless component is not going to be responsible for is deciding how this component will look. So yes, we could create our element and add those images all here, right? But then we don't want to do that because we actually want our cardless component to not, so this it should only think about what it should right? It should only think about, it should actually think about how to create them. So we are going to make a new component to this. So that component is going to be a card component. So let's make a card folder in our components folder, and inside let's make a new card component. New card component.jsx, and we need to import React like we always do. And we are going to export this constant card, which is going to be a new functional component that uh, will return a division, and inside we are just going to make it the same thing that we had earlier. All right. Now this key actually is still going to go on our component. We are going to make sure to do that outside. We want to still be aware that if any of those monsters update, I only want you to update that one. That one element that gets affected right now, that we know that what we want to do is we no longer have access to the monster to this. So what we have got to do is we are going to pass that monster the same way props from our app. As we pass monsters in, we are going to do the same thing, and we are going to pass an individual monster into our car component. So we are going to do props to do this component. Let's first import the card from card/card.component. So we actually don't need any of that, and then we got to pass a monster into our card component, right? So we are passing monster into the card component, and the card component gets it from the props and displays the name. And if we check, it is still the same, which is awesome. That's exactly what we are looking for. Now to add the styling to make it look closer to our actual application, just like before, I have the styles already written for you guys. We are just going to do the same thing that we did last time. We are going to make a card component styles, okay, and then we are going to use this card container class and the styling for it inside of our card. I forget to import, of course. Don't forget that we got to import those uh, to our final. Now we see this card has all of these stylings on it, right? Just like before. It just thinks anymore, but just like our final application, it is trying to look much closer. Now, what do we get? The image I actually get from this website called robohash.org. It's very easy to get unique images of those funky looking monsters just based on a changing number that you pass to the URL, which is really great for this. So we are going to add a new image, right, with an alt text of monster, and we are going to do our source, which is robot, except instead of this number, we are going to add our props monster ID, because the ID is a unique number. And then this is what's called your AI parameter. So with this parameter, I am essentially saying to use this set of images, and it's this. You can see what other parameters, but another great one we can add is 0. So if we add an ampersand, we can say size equals, and I want to do 180 by 180, 180 by 180. And if we say and we look at our image, wow, we see that it's there. We see we have those robo images, and we have our names, and now we are looking really close to the application. So let's just add the email as well. And instead of an H1, let's use an H2. And then a P paragraph, and let's just do procs dot monster email. And now when we look, we see it looks exactly like what we have in our application. And now then we look at these things. This is same as our application. So now in the next, what I am going to add is the actual search bar, and we are going to see now we can filter out and add more functionality to our component. Hey, it's Munish here. Just a quick question. Why do you think we keep breaking things down into components? I mean, in the previous videos, we created this card list component that renders this division with something inside it, some children inside it, and then we broke that down even further to have cards that are being rendered. And you might be asking yourself, why exactly is that necessary? Why can't we just put everything in this and have just one big file? GSX is not that simpler that dividing everything into all these small components and so many files is not that confusing. Before I answer that question, I do have a question for you and a little exercise. Where do we break things down into components? Pause the video here and think about what the benefits are of breaking things down into smaller and smaller components instead of one big giant one. Ready for the answer? Remember this when I told you that to be a great React developer, you have to do these three things really well. This touches on the first point, which is deciding on components. And if you remember our example where we had this little website that we broke down into different components, remember here and here and here, you can see over here that each part is a component. Now, the reason we would, let's say, if we had an app like this, we would not want to code it all way. One file is that the benefit of React is in the idea of this component architecture that can be placed and used in multiple locations. So that means that when we do something like this, sure, we could have kept all the cards in here without creating a new card component. But now this is more flexible because this card list can now be passed different properties. For example, instead of the monsters, maybe we have fairy tale characters in this card. Component can be used on a different project or a different part of the app because it no longer cares what it prints out. I mean, sure, it can print out this card component, but maybe we have a fairy tale now that we can just inject into here instead of this card one. And by breaking things down, we have making things more flexible because each component does one thing really well so that it can be used in other places. The bigger a file gets, the more joysticks we have, the more logic we have, the harder it gets to be used in another place. And this idea of breaking things down into small individual chunks is really important. And most good React projects break things down into a pretty small component file that the name uh, pretty much tells it exactly what it does. Just one small thing, and the other benefit that we will also encounter later on is that we also have this flexibility of performance improvements potentially, as well as having components that are really easy to test because they are so simple. Now, those are topics that we'll uncover later on. But the key here is that the reason we break things down to smaller and smaller component is that we combine each component with its concern, and that concern is that this component is only concerned about card list. This component is also concerned about card. Now this is an idea that we are going to verse. So if you don't, let's talk a little bit about state versus props. Now one thing you may have noticed is that we have this parent component called app that's pretty much surrounds everything in our app so far, and only here we have a state. Now this state we passed down to the card list component as well an attribute, right? Just like we have attributes, we sent down monsters on our state. So what you notice here is that as soon as we pass our state down to a component, this component receives it as a prop. And this is what you will usually see happening throughout our apps. We have a state, which often is something that changes because of user interaction. Well, what changes because of user interaction? The monster changes because when we click refresh on a page, we update the state monster from an empty array to a field and user. Now this state trickles down our componentry as props to whoever needs it. So if you remember this diagram, this idea of one-way data flow or unidirectional data flow, in our case, we have this app component that's at the top, it's the parent component. And then this component has a state that whenever something changes in the state, it will trickle down. If we pass that information down to whatever component, that will, remember, we pass it down as an attribute so that state gets turned into props into all these little components that we passed it down. In our case, the component gets passed down to the while the monster and they use it as a props. So remember that state usually lives in just one location or a specific state, and it trickles down as props. If we go back to our monster example, if you open up developer tools here, and remember we use the React developer tools. If you don't have it by now, I highly recommend that you download the extension from Chrome web browser. You see that we have the app on that, right? It shows me that the state is monsters, which is array of 10 and search field. And now this search field, we have not worked on it yet. So the key here is that we have these monsters and this state, if we go down, gets passed down to cardless. And right here you see that the props is monsters. And so even though it's the same thing, state turns into props when it gets passed down. Now, if we go down even further to the core items, we see over here that these card items get passed the monster prop because we only passed on one monster at a time. Now, you might also notice here the key that we gave each card. Remember, key is used by React to distinguish when multiple components are rendered one after another. So here, how we have all these card components, 10 of them to the list. If one of them changes, React uses this key attribute to say, hey, key we changed, do a quick render. So this is that internal React working for us to make sure that when they update the DOM, it's to be efficient and only update one of the cards if it updates instead of all the ones. But the reactive all tool is really useful to see how information is being passed out. Now again, remember the keys to being a great reactive helper. The second point was to decide the state and where it lives. Now Up until now, we have only had state in our app component, but as we move further along in the course, you will notice that we can put. So before we even get to that, let's think about this. I have here just a simple little tree-like structure, and you can ignore the numbers for now. But you can think of this as our app. Here we have the app James, that different component down here like in a tree. Now right now in this orange part, this is where the state lives. So let me ask you, if the state changes right here, let's say our monster grows from having 10 users to 20 users. That happens. Well, as state changes, it's going to happen with the state, and then we are going to announce to whoever cares that monster array has changed, and whichever component has those monsters passed down to is going to say, oh, I received new props. That means I have to re-render. So again, it's going to say, hey, I have new information, who needs it, and whoever needs it gets passed on that prop information, and so forth. So if you think of this as a function called to render, remember each component is a function that renders. So if state changes, it's going to notify this component and say, hey, run the render function again. Run the render function again, and the render function again. So we talk about deciding where state lives and how we pass on props. We can see here that there are some performance implications because every time state changes, we are going to have to rerun functions. Because the properties or the inputs or the function changes, now this idea of performance is something we'll talk about later on in the course a little bit more. But I want you to start thinking in terms of this tree that we are creating and how every time we introduce the state or data into our app, that data gets passed down as props. Finally, remember that this robo has that we are using right now is an API. Same with the user's data. So what we have done up to this point is essentially have an API call to get the users when we initially load the pages with our JavaScript HTML file, creating React app just simulate when we run it a fake server that sends these files. We get the users and it then gets each image of our monsters from another API the robo has. So this is what we have built so far, but we have a lot more to go to. So let's get started in the next video. And card list component, the next thing that we want to add in is our search field. So if we go into our final application, when we look at the search features, what we see is a text edit box that takes up users typed inputs and filters out the cards based on what they type in. So if I type in LE, it will filter out any monster whose name does not have LE in it. Now, how do we do that? Well, let's first go back to our application code. And what we first need is the HTML element that will represent the text input, and what we are going to use is an input HTML element. Now these import HTML elements are pretty much just basic text inputs. If we put on it, which is a template property that all inputs have, we can give it a different string. That string will help us get some features input that might want for different types of input. For example, if we use password, whatever we type will become hidden, and well, the one we actually want will be search, and what search gives us is the ability to put on this placeholder, which will essentially put a string on there when we have typed anything into the search field. So now we'll see search monsters, and that is the placeholder. But once we type, we see that it gets hidden, and then we can clear it away with that little things. So type search allows us to use that placeholder, but now that we need to do is we actually need to be able to hijack or take control whenever we user type something into the input, because we want to store that string on our state. And by storing it on our state, we are able to use it in order to actually filter out our monsters. So let's first figure out how to store that on our state. Well, the first thing we would do is actually add a field to our state that would represent what that stored value will be. So we will call it a search field, and we'll make it start. Next, what we'll do is we actually have access to this method on our input called on change. And what on change does, it fires with this synthetic event, which is essentially just a event in our browser, right? Whenever the input is changed, uh, so whenever the user types or removes anything, but let's just take a look at what that looks like. The change is actually this function where it represents the synthetic event we are talking about. And for now, let's just console log e and we'll see what happens. Let's go to our browser and open up our terminal using right click and click inspect element, and then hitting the console. Now whenever we type anything into our input, we will see our onChange fire, which was the function that we wrote that locks that synthetic event. We also see that it changes whenever we remove any of the characters, and this is because it's literally, as the method says, whenever the value in that input changes, the might on change event fire the on change with whatever function we passed to it. And what we'll see on our synthetic event is that it's this huge object with all these things on it. And this is because it's a native event that the browser uses to do all kinds of things, right? It gives us a lot of control, but we actually don't need to worry about more than percent of this stuff. The main thing that we do want to look at is this target value. There is a get and there is a set, but that mainly means that we can either get the value or set the value. But we don't want to set the value, we just want to get the value, actual target value. And what it will give us back is that timeline. And we can see if we it so when I say that it gives us the HTML element, it because it's the HTML element that fired into events. So if we now log it, we see that there's our input, and we can actually on the page that element is, and this our search element, right? So what we want of this is actually the value, and value is a property on the input that will give as literally the string value that it's hold, right? And see, as we type it, we are getting that string value, and that's how we are going to be able to store that on our state. Now, how do we store this? We can do this by calling set state here the same way that we did when uh, we got our users went inside of our component did mount method. So what we can do is call this set state, and we can pass it that we want our search field value to be the
target value. Now, if we want to see this,
actually persist, right? If we want to make sure that our state was being updated, normally what we would think to do is just console log after we call this dot set state. So we would think that if we called console log this dot state, that will would see our target value. Now let's actually test this out, and we see that as we type, it looks like our event is firing, but our search field key is always one letter behind, which means the first time we type D, search field was actually not updated, right? Why is this? Well, this is actually because set state is in a synchronous function call. And asynchronous versus synchronous is a big thing in JavaScript development, especially in React. Synchronous action is something that we can expect to happen almost immediately. It's something that pretty much happens in JavaScript, knows the amount of that will. So a JavaScript will wait for that thing to finish before it continues, right? Running the rest of the code afterwards. An asynchronous action or event is something that actually taken an indefinite amount of time that JavaScript does not know. So what it does is it actually runs the rest of the code after, and then when the asynchronous event finishes, it then runs that finished event. Now, I know this sounds confusing right now, but I promise that we'll cover it later when it makes more sense to do so. So right now, the main thing I want you to focus on is just that this set state is actually not happening immediately when we would expect it to, which means that yes, our state will be updated with this value that we have set there. But it's not going to happen in the immediate sense that we would expect it to. Instead, what we would do, in order to log our state, there is actually a solution that React has given us, and it's going to be the second argument that we passed to set state. Now it's going to be a callback which runs after a set state is finished. So after that state has opted out, it function that we pass, and here we can log this state. And here we will see that when we type, now we do see our newest latest value. So that's a thing to remember. If we wanted to see or do something with our state right after we said it, then we have to do it inside of the second argument function that will get called right after such a state. Okay, now that we have our search field being stored, let's actually filter out our monsters. But let's return our code back and get rid of this part that we don't need. So let's remove that, and then we don't need these brackets either, because all we want to do uh, is just color set state value. Hey, it's Manish. I want to make a quick note about this on change event. Let's demystify these things now. The first thing I want to point out is this on change. Remember, in JSX, it's not actual. Remember this diagram. When the DOM changes or react to a user input, in our case, searching for a monster, it's going to say, hey, there's an event. Somebody has just typed in something into the input. However, what React does, remember, we don't manually touch the doll if that were the case, DOM, we would be using the onChange event natively in our HTML using something like this, but because we are using just JSX, and by the way, if you are not familiar with HTML events, I will link to this in my video that talks about this, but again it's just something that the DOM gives us in order for us to interact with user events. React actually has something called synthetic event, and I do recommend that anytime you have questions throughout the course to Google things and go visit the React documentation, because while they the ultimate source of truth when it comes to React now, what are these synthetic events? If we go back to our diagram, when a DOM event happens, because let's say user clicks or types something is an event input, the DOM onChange event is going to say, now React intercepts that and says, oh, something has changed. Let me go tell my React tab that something, and this is what a synthetic event is. A synthetic event is kind of like a fake event that we pretend is a dumb event. But it's something that, well, our React robot is telling us, saying, hey, there was an event on the DOM, what should we do? And this is our synthetic event you see here, that is camel case. So it's not actual HTML, but a synthetic event on change that we use to detect whenever that event happens. We receive that event because something has happened, and then we update the state. Remember, state is simply something that usually changes in our app due to a user action. In our case, the search field is going to change because somebody has typed in into the textbooks. Now, if we look at this code over here, some of you might be asking why we don't just run this function. If you look over here, all we are doing is actually defining the function and not running it. We could extract this entire piece of code and put it up here, which by the way, we will in a later section, because we are not running you here. We are just saying this is an anonymous function that gets triggered on change, and this is an important distinction here, because you would never run set state in render, because well, that's going to create, you can actually try it by yourself trying to call set state and render, because every time you call that state it renders, and every time you render it's going to cost, that state is just going to create a app. So what we are doing here is we are actually defining a function, not running it, just letting them know, hey, on change, I want this to happen, and react internally with this synthetic event to say, anytime on change happens, it's going to be just run this function. Now the last part is this over here. Remember how that this does not get logged right away. And that's because once again, React Smart, we are not actually interacting with the DOM. What it's going to say is when we do set state, it's going to say, hey, we thought we have some updates that we want to make to the, can you do it for us? And our little robot is going to say, yeah, I can do it. But you know what? I know when the best time to do is, I know when to do it. Just let me handle it. I will take care of it. So it actually does not happen right away. What it does is essentially it schedules and batches work. So if there may be multiple updates that need to be done, then it can actually optimize that for us. And that's why React is good, right? Because it figures out for us the best time and the best way to update the DOM. We just tell it what we want and update it. It's declarative, but we leave that internal working to this little smart that constantly improving with new updates, so that we don't have to worry ourselves with the DOM. And that's it. Let's go to the next section. Okay, now that we have our search field value stored on our state, let's actually use it to filter out the monsters where their names don't match the field. Now how we will do this is in the render. We don't want to actually modify our states monster array because we want to keep the raw data in case somewhere in this component we need to use the base unmodified array. What we will do instead is making a new array using the dot filter method that we have learned. So what we'll do is we will actually first use a concept called structuring. And what the structuring allows us to do is pull properties of an object and set them to constants that we put inside of here. So the syntax is we say const and then we put our bracket notation, and here we'll use the actual objects we want a structure from. So the state object is what we want to pull the properties of, and what we want to do is use the same property name that we want to set as the constant. So when we say monsters and search field, like this will be pulling of the search field value and the monsters value of our state object and setting them to constant called monsters and search field. This is the equivalent of saying constant monsters equals this state monsters and this and const search field is equal to the state search field. It's just an easier way and a quicker way for us to write this out. And now that we have our monsters and search field, what we'll do is set a new contest called const filters monsters that we will set as our monsters don't filter right, and we are from our filter method. We get back a new array based off the function that we passed into it, where we will get the monster that's irritating over. And what we want to do is to take the name called to lowercase on it, which is a method on all strings, and here we see converts all the alpha beta characters in a string to lowercase, and we want to do this because it to be case sensitive. If we did, we would just not use the two lowercase and then we'll call dot includes. And what this includes method does is similar to our array method. It just checks whether or not the strings value we pass inside of our includes is actually in the string that it's being called on. So here we'll use our search field, and we also want to lowercase it because again we want to make sure that if the user types in capitals, we don't want that to be uh, case sensitive either. So includes, just like the array methods, includes will return true or false based off whether not this string include the string we are passing to it. And now instead of passing in our state of monsters, we'll just pass in our new filtered monsters. And now we see that as we type we are filtering out the monsters that don't have what we are typed in inside of their name. Now you will notice that our component is actually a re-rendering every time. This is because whenever set state is called and the properties change, React renders our component. It recalls the render method, which means that our filtered monsters method here is actually getting called again. And this is great because what we have done is we have triggered this set state whenever they have typed something, in which in turn set the state value of search field, which then in turn causes our component to re-render and recall the render method, which then filters out the monsters by calling our monsters.filter again, setting a new array which it will then pass to our card list, which then renders card list. And this way we are able to just dynamically update our card list based on what we are typing in. And this is what's great about React, is that React is able to take control of what to render. What to render in its views without us having to do all of the extensive calls of showing elements and hiding elements. React is able to do so far for us. As long as we understand the rules now, we will definitely explore this in greater depth a little bit later, because right now we have to just expand upon some other concepts. But I promise you that we will take a deeper dive into how this works in just a little. Now that we have our search component, we might actually want to be able to use this component multiple times, because if we look at the code for our input, all it is just an input that does not need any local state, even though it seems like we are calling set state in our input. It's really just a function that we are passing from the context of our app component into the onChange handler of our input. But this means that we can probably move this into its own component, because maybe we want to reusable search component. Well, how would we do this? Well, let's just make a new component called search box. And we will create the usual file search box dot component dot .jsx. Now, some of you might have noticed, why is it that some of our files have in some have JSX, some have JS? Well, you remember how I mentioned earlier that create React and hides away some of the configuration for Webpack and Babel. Well, what Babel does is it helps transpile down any of the modern JavaScript, including JSX, JS styles files that we write into older versions of JavaScript in the public folder. Then we finally run our build script inside of our script file. Now in this transform, if we look at our docs file for Afghans, we actually see that it says JavaScript Babel down here. So even though we are writing JSX code here, right, because we are rendering HTML using JavaScript, or Babel here knows that it should probably run this regardless through a transform, even though it's a JSX file type. We will explore this much later in this course when we actually write our own web page configuration. But right now, just know that whether or not you write JSX or JS in the context of create React, that you can write in both file types. But we want to write docs in our, because we want to be explicit. We want to know what if we are going to write JSX while this file type is JSX. We are also going to create our search box dot styles dot CSS, and I have included the states for you, and you can find this code here. So you just want to copy that file and paste it in here, and then you want to import it into our search box component. So let's first import React from React, and then let's import in our style sheet. Now we are going to use another const. Let's go a little deeper about functional components. So functional components Unlike class components such as our functional components, they don't have access to state because they don't have access to constructor, which is a class method on our component that we import from React, that we extend our classroom. They also don't have access to lifecycle method. They don't have internal state and lifecycle method because we don't always need to use lifecycle methods or internal state. Sometimes all we want to do is render some HTML, and that's what a functional uh, component really is. Unlike a class component, a functional component is just a component that gets some props and, uh, and returns some HTML. And we will figure out as we build our apps and see more challenges when to use each. But for now, the main thing to remember is that if you don't think you need internal state nor access to lifecycle methods, then just use a functional component because it's easier to read. It's actually easier to test as well as see later in this course, and it's in some ways smaller and easier to reason about. So we will just copy over the input that we want inside of our search box component. We'll apply a class name of search to it because that's where our search box styles are applying those styles to here. We'll keep this type because we know that is going to be search, and then as far as placeholder goes, we might want this to be dynamic because maybe another place that wants to use search box does not want the placeholder to say search here. Let's say they want to search pupil or anything else. We want place to be a prop that gets here, and as we learn with our structure, we can structure that prop of the props object because all the props come in as one big object. So let's destructure it off and then pass it into our placeholder. And then on change can be another prop that gets passed in, which is a function under the name of change, and we will just structure that one of the state. And then we will replace the value inside of our change right here. Now let's export our search box out, and then inside of our ABC we can import it in and start using it. So let's import in our search box from components slash search box components. Now in order to replace our input, we are just going to copy over some of those properties. Now we know that type is already on our search box components, so we don't need this. We do need the placeholder because we want to be a prop that we pass in. And then instead of handle on change, we are going to say handle change, and then we will pass in this function. And now let's get rid of our input and we go back to our application. We'll see there's our search box, and we have still got our functionality, but now we have got a reusable component that we can use in multiple places. And this is what's great about React, is this component driven style of writing code. Our search box is just a presentational component that pretty much styles an input, and then it takes any functionality that it might need in its handle change property. But now we have this reusable search box component. And this is great because we can minimize the amount of repeat code that we have, write an input and then style it inside of a local file, because we can separate it into its own component. This will become much more apparent as we start building larger and larger applications where the code gets reused. Right now, the benefits might not be so obvious, but it's definitely the style that we want to code. And this is one of the huge advantages of React, is writing these smaller and smaller reusable component. Okay, let's continue. Hi, I'm Manish. Some of you might be wondering why we don't add state to search box. I mean, it looks like what we are doing is adding the on change over here, giving it a function. And this function goes up a level and letting our app know that there was an event. But search box should not that have the search field state. Let's explore that. Now I want you to think about this. Pause the video, think about it. Let's find out what. Remember our third point over here. A good reactive helper decide what changes when state changes. Let's think about this. Now the reason we don't change the state in search box and instead we trigger whenever an event happens to handle change up here in app.js is because our other component card list needs to have that information, right? Remember the way we filtered monsters was by using the search field state to filter based on the user input. So the way to think about this is like, so we if we had our app over here and this is the we have the search component and the card list component. आइए 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 If the state was only here in the search box component, there's no way for the uh, this component to find out about it. Remember, because of one-way data flow, data can only flow one way. So there is no way for, let's say, the search for state to move up and down to the cardless component. So instead, we want to place the state in a place where it gives us access to whatever needs it. In our case, both card list and search box need that state, that search field state. So we move it up, and the way we architect things and React is that when an event happens on a component. Let's say a user clicks or types something, well, that event triggers the React event system and says, hey, something has happened. Create an event handler like handle input or handle change, and it's going to go up and let the component that has that state know that if something has happened. You need to update state and how far up that goes. Let's say we had a component, we notify the component that has the state as far up as we need to in order to pass down that information to the components that need that information. Now, if you don't get this right away, this is something that comes with practice that we are going to explore throughout the course as we build more and more projects. But I want you to pay attention that you want to decide as a React developer that changes what events that the users take, how far up it goes to let the state know, and you want to move the state in a high enough position so that we are still able to pass down that information to different nodes, but at the same time, if we had, let's say, a state in here that the only people that care about it is these two components 4 and 5. Well, if that's the case, there is no point bringing up the state all the way. You want to place the state over here because all these components are belong to one line. This is a topic that we and structure state is a very big topic, and yet but I want you to start doing this right now here. Guys, in this lesson, I'm going to take a deeper dive into writing methods on classes because right now is actually a good opportunity for us to explore a very fundamental thing in not only JavaScript but also in React. And that's the idea of writing our own methods on our class component. Right now, we pass in this anonymous function into our search box handle change in order to set our state, and we know that we have seen the this keyword a couple of times now. What is it actually representing? Well, this is a special keyword in JavaScript that references the context in which it's being invoked. So what does that mean? Well, when I say this dot state, we know that I am trying to reference the state on our component, right? Our class component. The only reason that JavaScript is able to say, oh, when we are calling this dot state, I want the state object on our component is because this keyword is set to the context of our class component. Now the weird thing is that in JavaScript, when we write our own class methods, we'll see that the this keyword actually gets bound differently depending on how we write the class method. Now we have already seen class methods in our app component. When we look at, say, which is a lifecycle method as well as the render and inside of these method format where it's the function name but this keyword is actually now the reason that this is actually happening where this context is getting bound inside of this method is because when we call super, we are actually extending the functionality that exists on component which we get from React that has these lifecycle methods, and render because we didn't write this. We are like borrowing them from component, and when we borrow them from component actually sets the context of this inside of them for us to our class component. If we were to write our own method, for example, to represent this method that we are passing in, we would have to be careful about how we write it. Now let me show you now the reason in the first place we even want class method is because there's a chance that we might want to use it more than that, and we don't want to write code here. We just want to put it in one place, pass it in, and then changes it in one place if we want not have to change this thing. So now how we would do this is we would write to handle change method here, right? Taking the same format that we see, and it would take some event, right, which is the synthetic event we are getting back from our, as you remember, and then we call this set state in it, and now we are able to actually pass handle change into our handle change property on our search box. Now we can write it like this because we are passing the whole callback through to it. Right is being referenced in the function definition. So we even thought earlier we were explicitly writing it out like this. This is the same equivalent thing because this door handle change is referencing this full function with the e-signature. But if we were to save this, we'll actually see that our original conversation, which is about this context, is undefined. If we start typing, we'll see that we get an error. It says that cannot read properly, set state of undefined, and it seems that this is undefined. Well, why is this? Well, this is the way the function behave in JavaScript. When we put handle change on our app, and all it knows is that if we say this not handle change inside the context of our app, it points to this function, but it does not actually set the context of this. The reason for this is because JavaScript by default does not set its scope of this on function. You have to actually explicitly state what context you want this to be for us. We want this to be our app component and the method in which we want to it to define it in our constructor, because our constructor is the code that runs first before anything gets called, right? So we want to make sure that the context of this is correct in all of our methods written. So what we could do is we could say this dot handle change is equal to this dot handle change dot bind, and then this. Now what is defined behind what I find is a method or any function that returns a new function where the context of this is set to whatever we passed to it, and the context of this that handle chain, right, is this keyword that is defined inside of our constructor, which knows that it's our component. And now if we save, we'll actually see that I will work as it was before. This is actually a very way of writing code, because that means that for every new class method that we write, we have to bind it. We don't want to have to do that. We can actually leverage its 6 arrow functions and a unique characteristics about them that allows them to set the context of this in whatever it was that declared it in the first place. So what do I mean? Well, arrow function automatically allow you to set this when this thing is defined. So when our component is get a script for the first time, and it's like, oh, I instantiate this new app class, it checks inside and it sees that there is the handle that points to an arrow function. So then it defines the arrow function based on what code we have given it, right? And the moment it sees this keyword, it's like, on this is an, I'm going to automatically bind this to the place where this arrow function was defined in the first place. And the context of this arrow function is AR app component. So that's the crazy thing about arrow functions, is that you actually cannot call unbind on them. They automatically got what's called logical scoping, which just means that they bind that this context to the place where they were defined in the first place. And we can actually see this now that it will continue to work, and it did before, right? Even though we are not calling the bind in the constructor anymore. So this is really handy for us because it saves us that extra step. In order for me to prove that this is lexical scoping, another way I can browse the highest levels of context is our window object. If I were to define a function called new func, and what we are logging is console dot log this when we invoke new func, we'll see that this is that window object when JavaScript show us define new func to this function and brought it into existence within our JavaScript context, so we could start using it. It had to lexically scope this is to the window object, because the window object was the context in which our new function, our arrow function, was given its existence. This is the same case with our handle change method. When handle change was declared, which means that when JavaScript first created our app component, and it also defined all of the methods on our component, including handle change, and it showed that this was an arrow function. And because of this, when this arrow function came into existence to JavaScript, it was going to bind any references to this inside of it to the context in which it was defined, which is our app component. Just like we saw with our myfunc in the browser, that's what happened with our handle change. And this is great because if we want to write class method, we just write them with this arrow function. And now the context of this, what we expect it to be without us having to write it. Binding code, if we were to write it in the other way. So with this in mind, it makes it easier for us to write our class component and their methods. It's an app component, and here we have our component. This important part is the render uh, bundles. Very beautiful page. Now here we have four bands with different ways that we are assigning the handle click function. The first one actually runs the function like this because of this brackets. Second one and quick one looks like this. It's defined right here inside of the component and it locks but one clicked. The next one handle click 2 is up here. It's saying this dot handle click 2 equals this dot handle click 1 dot 1 at 2 click 1 is here and binds to this. And then the next one handle click 3 is a function of, because this is a part of a class, its method that's using arrow functions. Okay, so what do you think is going to happen? Remember, this is just a simple component. All we have is these click handles. We actually have 1, 2 and 3 and all three of them are being used in different way. I want you to predict what's going to happen. First, I'm going to refresh the page, that I'm going to click on 1, then click on 2, click on 3 and the click on 4. I want to pause the video and write down what you think is going to show up inside of the console. So I am going to open up the console over here and we are gonna go one by one. So write down what you think is going to happen. This is a little tricky. So if you don't get 100%, don't worry, you are not a terrible developer. We are just learning. Ready? Alright, time for the answer. I am going to refresh the page. Alright, and we see you right away that there's console. So let's click here and it looks like buttons one was clicked. I didn't click this button, which just happened. Well, we are invoking the function whenever we render, right? So here when React renders this, it runs this function because, well, we call it right here. This is why we don't call a function when it's an event handler. We assign it a function so that when the event happens, it actually runs. So if I click on one here, no, nothing happens because there is nothing assigned to it. This is just, we pretty much just said, hey, just run the handle click function, that's it. So we don't want to do that. What about this? Let's click on to there. I get button, one click. Why is that? Well, because we now assign handle click 1, which is over here, and we ran this. Awesome. Now if I change this to have this keyword in it, you see that this refreshed, and this initially is the app, but as soon as I click on bond 2, I get undefined. And this is something that we talked about before with the this keyword. Now this undefined over here, if we wrote it like this, would actually refer to the actual button, the actual element here. Alright, enough of that. Let's go back. Let's click on this one over here. Well, let's click on the first thing, but button one clicked. Why is that? Handle click 2. And by the way, I don't know if you can hear this, but it's raining really hard. So if you cannot hear that, sorry, but I swear it's just an rain. And all right. So handle click to here is equal to this dot handle click. Now we run this console log. But if I change this to this now, I click on 3. Look at that. This is now the app. So this is what we are doing with. We are making sure that this is going to app because we are going to use it. And what happens when I click here? When I click on 4, I get button 3 clicked because handle click 3, which is right over here. And while this, just two things, if I now console log this and I click run, let's click 4 there. Look at that, I get the app without having to do this ugly bind up here that often confuses people. uh, and did you get that? If you don't worry, these are pretty much the rules once you memorize them. That's it, it's fairly simple. So I will see you in the next section. Now that we have created our card component, our card list component, and our search component, pretty much done with the most of the functionality in this application. The only thing we are missing is a little bit of styling. So the first thing we need is to add the title, and I'm just going to add it as an H1 here at the top of our approach. Well, this is a Rolodex, and then we need that font because you will see that we don't have this font now. This font get from Google Fonts, googlefonts.com, and we can see all these different fonts that Google allows us to use in our project. So I'm just going to find the one we want. From that, I'm going to hit this little plus icon, and Google gives us a link that we can add to our index, that HTML inside of our head. And we just add it at the bottom here, and now we have access to this font in our project. Now if we go to after X, I'm going to add a new rule for H1, and I'm going to say font family is big yellow rule. Font family is equal to big yellow rules. I'm also going to set the font size to 72 pixel, and the color and now if we look, we'll see that our project has the same font now, which is really awesome because Google has this great uh, for us. And now what we need is the background we are going to put into our index, that success, and this is a file that gets generated by create react. The reason why they have already added the styling to the body and the code is because create react app wants the exact same base styling across all browsers. So different browsers might run different things like a different font or different margin or padding. So create react app is just trying to equalize that. When the project starts by inside of this body, we are just going to add this linear gradient to our background. And you can make any gradient you want. I just made this one, and we'll see our project is finished just like that. We have built a project that has filtering, and we understand now how components are created. Now that we finished building our websites, it's actually not live yet, but we can actually host this really easily using GitHub pages. So create react app has made it really easy to use the GitHub pages of service. And GitHub lets us host a static website for free, which is really awesome. And it's actually really easy. There's just a couple steps we have got to take. The first one we have got to do is we have to go to GitHub, and then we have to make a new repository. Now I'm going to name my repository Monster Rolodex after our project, and then I'm going to copy this key right here. I'm going to go to our terminal, and then I'm going to do two things. First, I'm going to connect our actual project to that repository we just made by doing git remote add organ, and then that key we copy it. Next, I'm going to actually include the pages package by doing yarn add gh pages. Next, I'm going to go to our package that on file, and I'm going to do two things. The first thing I'm going to do is I'm going to add uh, home page. I'm going to actually type in https dash slash slash homepage, which is the name of my GitHub username. So you are going to use your GitHub username here according to your name, and you are going to do github.io. And then the name of the project that we made on GitHub, the name of that repository for me, it's uh, it's Monster Rolodex, the one we just created. Then I am going to add to a script. The first one is called pre-deploy in a script, and in this principle I am just going to call yarn build, because as we remember all of our react out into that final code that our browser needs. And then I'm going to call deploy, and this one I'm going to say pages gs dash pages dash d build. Now this is going to run pre-deploy before it runs deploy, which is really awesome, because uh, npm script yarn bot know to run any script that you have pre with before you run the actual script. So it's going to run pre-deploy before it runs deploy, and then it's going to serve up. That's working on a project. Now we are going to go back to our terminal, and then we are going to run our new deploy script. And now we actually see it runs our pre-deploy script first, and then we are going to see that it runs our deploy script right after that. Now this is going to build all of our project files that we need for the final project, and then we are going to add, and then we are going to write a common message adding files for GitHub pages. And now we are going to push this up. So once this is all pushed up, now to our final project repository, we are going to go back to our GitHub, and we are going to refresh right, and that we should see all of our files in here. And if we now go to the settings, and when we scroll down, we want to make sure that the source is actually pointing to GitHub pages. If you are just pointing to this, just make sure to set it to GitHub pages launch. And now if we go to our link, we see our website is live. It's actually serving up this URL, and that's awesome, because GitHub lets us serve these static websites for free very easily and very quickly. And you can see how if you wanted to build a quick static website using React, it's really easy to build it and then serve it using create React app and GitHub pages. Now when we actually build our final application, which is very more dynamic e-commerce websites, we are going to actually use databases and we are going to leverage a lot more code that would not get help, would not be enough for us to serve. And I am going to show you how we are going to take all of these things that we learned building this application and then expand upon them in that lesson. So I hope you enjoyed this and look forward to building your first big React project